Hey, everybody.
Brandon doesn't
Wants to
even
be
get a number anymore. He doesn't even get
Because he's
ranked.
not
No,
on
it's
this
like a
correct
different
account.
account and it's annoying.
I
I wanted the number
know.
one crown.
No crowns for you. No kings.
Okay, it's hashtag.
Well, I'm glad you survived the store, Katie. Because holy crap, the decision to go to Costco on the Sunday before Thanksgiving here in America is it's brave. It's brave and insane, is what it is. And we would might end up in jail for homicide if we had
We
done that
almost
kind of
did.
thing. Well, Winco
Oh
wasn't
yeah,
so
you went
bad.
you went the other day and Mike almost had to leave the store.
Well, we went to Winco. It really wasn't too bad at Winco. It could have been a lot
Well,
worse.
Well, it was.
except that you both got out of the car and noticed something.
Yes, we were wearing. Well, we noticed it on the drive there. We were both wearing the pretty much the exact same Nirvana sweatshirt. So Mike took it off when we got to Winco, which was actually a smart choice because by the time we left Winco, I was like dying. I was so hot, but I couldn't take mine off because it's a small sweatshirt. So
Yeah, I was
nothing on
warming
it.
up, and then I hit the produce aisle, and it was a little chilly there, but then I warmed back up. But you do want to murder everybody because they just
Yeah.
stop and
Well, I
talk.
only had one real moment, and it was when I was looking for the cinnamon sticks in the spices, which I couldn't find, and we really don't need any because we have some. But anyway, there were two ladies just
They're gonna go.
gabbing right in front of the spices, and it's a crowded aisle, and I was like, "Can you bitches move the fuck out of the way?
Yeah,
What are you
I
doing?"
Yo,
had to
Gabbit
step out.
Gabbis, get out of here.
And no, I was like, okay, just contain yourself.
All
Anyway,
right.
yeah, it's a trying time here. Oh, my dad got the portal in 4. Hey, good job, Dad. Good job, Bob. He's on the 4 train with me.
Cool.
Yeah. Anyway,
All
look,
right.
it's my show. I'll get started when I want to get started. Don't be
It's
impatient.
our show,
You got
Liz.
stuff to do.
Wow.
Well, I'm running
This is
this
a
episode.
fellowship, not a
I'm
one-ship.
running this
Wow.
episode.
Never mind.
He doesn't
Never
like
mind.
the banter. He just wants to get straight to it. He's like, "All right, I got apples to wash
Hey,
in the crock pot."
listen, folks. If you
Oh,
don't want the banter, go listen to the shots.
yeah. In fact, Jack, we kind of got a Jack move being pulled in our house. Mike is making apple butter. So we got apples in the crock
Ooh.
pot with cinnamon and brown sugar, and the house is going to start smelling amazing.
Nice.
Cinnamon, brown sugar, salt. I didn't see any cloves, so I didn't put any cloves in there, but it'll have vanilla.
Yeah, I don't think we have any clothes. You could have put some like a star anise in there.
That
Star anise
the
or
the
something.
way you spun off those ingredients it reminded me the other day we listened to a hip hop song and all it was ingredients for Indian fry bread and it was fabulous. We'll need to send that to you.
That sounds good. That reminds me of the there's a Tool song. I fucking forget what album it's on. It might be Anima. But it's basically it's like this guy speaking in German, like he's doing like a rally, like he's Hitler or something. But he's just doing a recipe for deviled eggs. But it sounds like a Hitler speech. It's great.
You showed us that
Yeah,
before.
yeah. I think I
Yeah.
played it for you. Anyway, I love it. All right, we will get started. Brandon, count me in.
And in 4, 3.
Hey everyone, welcome to another episode of Cosmos with Cosmos. I'm Liz,
I'm Mike.
I'm Brandon.
and we're here for another edition of High in the Sky for December of 2025.
Can we stop at the time?
December.
I mean, it's just,
2025.
it's not,
I mean, we have a week to
cool.
go until it's
Well,
actually December yet.
no, but time
But-
has gone by so fast.
And you know what? For more on time, check out the episode on time.
I was gonna be like, hey, you know what you could do? Check out our episode. Okay.
But
so,
the 2020s no longer seem like the future to me. Like 2033 sounds like the future, but 2026 doesn't sound like the future anymore. It's
I
like the
don't know.
inevitable march towards our demise.
yeah, I don't know if anything sounds like the future
Yeah.
anymore to me.
And that's our happy thought of the day.
Yeah,
Or
Our
eventual
inevitable march to our demise.
Maybe I'll rename my drink to that.
that's a good. Oh, yeah, nice.
Jack, what do you? I'm reading your. Jack's making a key lime pie with vanilla wafers and coconut crust. Oh, okay. Our neighbor told us about a key lime additive for drinks, and he adds it to a gin and tonic, and it makes the gin and tonic taste like a key lime pie, basically.
What is
Where
the
was I
additive?
in all this?
You were making the drinks, and then I said next when we go to 3rd Street, when we're in Bend next, we should look to see if they have that additive so we can get it.
Sounds nice.
I missed this because I was making drinks.
Yeah.
While they were eating pizza.
We said you could come eat pizza first and then make drinks.
Yeah,
they
but
were
then-
stubborn. They were
Priorities.
stubborn.
Yeah.
I understand.
Anyway. Speaking of drinks, Brandon, what are you
Yeah.
drinking?
Ooh, I am drinking the Winter's Eclipse.
Ooh, that's nice. What's in it?
Well, I say it because there are two drinks, because one's eclipsing the other. See,
Hey.
those on the podcast are missing out on my wonderful visual aids here. So the first drink is just my favorite afternoon tea, jasmine pearl.
Ooh,
And then in the other hand, they have the alcoholic drink, which is tequila, sparkly, and cranberry.
nice. That sounds nice, actually.
Yeah.
I like the jasmine pearl tea. What kind of flavor is that? Is it jasmine?
So imagine you go to a Chinese restaurant, you get the
Okay.
tea. That's what it is.
Oh, okay. That's
Okay.
nice. That's nice.
And it's caffeine free. So
Oh.
great afternoon tea.
Hey,
For me.
Why?
I would take
Why
it
would
as
you do
if
that?
it's in
Because
that
if I
amount.
take caffeine after 12 p.m., I am just going to stay up until 3 a.m.
Really, see, caffeine doesn't affect
Yeah.
me that way, but whatever.
Puts me to
Each their own.
sleep.
Yeah, it makes my dad tired at night if he has a nighttime
So-
coffee. It makes him tired.
So we have the spectrum. Stay up all night, does nothing, puts you to sleep.
Yeah.
Caffeine's a wonderful drug.
Caffeine's wild. Jack's got a raspberry dark chocolate latte. Oof, God, that sounds good. That
Sounds fair.
desserty. Mike, what do you got?
I have Clash of the Physicists.
Hey.
More on that later. Also known as, I'm going to regret this later, but I'm still going to do it because I have two of these, and it's a pretty strong drink. It has bourbon, hard apple cider, and I think there was something else I put in there. I don't remember what it is, but hard apple cider and bourbon, and so yeah, I'll regret this later.
No, that's one of my favorite drinks is bourbon, or technically it's Irish whiskey and cider, hard cider. That's one of my favorite drinks.
Oh, yeah.
Oh,
yeah.
I put there is like a cinnamon. Oh, a honey syrup. Honey syrup was in it.
Oh, that's what
Is in it.
Nice.
Also, I put a little cinnamon syrup in there to get a little bit of cinnamon kick.
Ooh, nice.
When you put the cinnamon in there, do you do the pinch move? You kind of throw it in the drink?
No, it's a
It's a
syrup.
syrup. It's
It's
a
a
syrup.
syrup.
Oh, that's
So
right.
I didn't. That
For the
would be
best.
messy if I did a pinch move on the syrup.
And Elizabeth says that you can have jasmine pearl tea. That is a green tea, so you can get it with caffeine. If for those who need a caffeine, a hot. See, I thought about making a hot toddy because it's a little bit chilly and I was a
Same,
little cold.
yeah.
But then I was like, you know what? It's gonna get cold and blah blah blah. So I didn't. Instead, I am drinking what I'm calling brain matter. Because it could be Halloween all year long if you want, and the glass fits with this. But it's basically canned cranberry, gin, tonic water,
And simple syrup.
and simple syrup, and the
And
cranberry
brains.
looks like brains at the top in my glass. Although the glass, in person, it's more of a white, and then
Yeah.
it's a distinct kind of brain mattery-ness.
It's
on
pretty
the top.
distinct on camera here.
Okay, good. It's nice. I like it. Anyway, not too
I,
bad.
I forgot to put the simple syrup in, and then I had to add it
That's okay.
after the fact.
That's
so,
all right.
I mean, it was just stirs in.
Alright.
So
That's all right. Cool. Well, blend some of your apple pie filling juice in your drink. Oh, that sounds good. Okay. All right. Well, if you like our shenanigans and our banter and whatever, then follow us on all the things at Drinking Cosmos on Twitter and Cosmos of Cosmos everywhere else. And also check out our every other Wednesday shots of astronomy down your gullet, just short form episodes where we single out a little, one of us does a topic that the others don't know what it's going to be, and we have lots of fun with it. So check those out. Also, follow some of our friends of the pod out there, Wildixia, Wildixia on Etsy for some really cool art. Our buddy Ron Proctor at the MrProctorShow.com. He does some cool stuff with Blender, which is a CGI making 3D modeling software.
I just like watching things turn around to a beautiful oblivion.
Yes. and if you're in the Council Bluffs, Iowa area, Jack, go to the Rolling Bluffs Planetarium there, rollingbluffsplanetarium.com. If you're in the area, check out what he's got going on in his dome in that area of the country where there's corn. I always think there's corn. Is there corn, Jack? I don't know. Is there
I
corn?
think we have this conversation like once a year
Did we
about
always
corn in
talk
Iowa.
about corn in the
Yeah.
Midwest? I don't know. It's just I know Nebraska's corn because they have the corn huskers. That's
Look at you breaking
what I
out
know.
like a football
Look
team
at that.
mascot.
That's what I know. Anyway, we do have some rules, a little game, if you will, if you want to play along. If you happen to hear any dogs barking, which doesn't happen too much anymore,
Well.
take a drink. Oh, well, yeah, you never know. And then if we make any Star Wars or Lord of the Rings references, take a drink. So, when we're
Sweet.
getting nerdy with it. But I think that now is the time that we should start to get high in the sky for December
Pew, 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 pew,
2025.
pew.
Woo! Now, our constellation highlight this month, I decided to go down south.
Didn't we do
again.
that last month, too?
Yes, because
Alright, cool.
you know what? We never really highlight the southern hemisphere, so I'm trying to do it a little bit more to be equitable to the globe.
Yeah,
and
we got we got to help out our worldwide
worldwide
fan
audience,
base.
Yeah.
We got people
Technically,
people in
right?
New Zealand,
Technically, yeah, sure.
people in other places south
Yeah.
of the
You
equator.
never know. I don't know. But there's a whole other half of the sky in the southern hemisphere that has stars and constellations and cool shit. So even if you don't live there, if you go on vacation, here's something you can look for. And this
Sweet.
constellation is Vela.
Hey,
Ella. Hey.
Hey.
All right, I'm sorry. I'm sorry, guys.
And Vela is the sail of ships is what it means. And it was actually part of a single constellation that was broken in 3. The constellation was Argo Navis, which was the Argo, the ship that Jason and the Argonauts took to
Drove
get
around the ocean with
Golden
the
Fleece.
sea.
No, they just went to go get the Golden Fleece off of the... was the sheep golden, or was just its fleece
No,
golden?
they had to drive it on the ocean or drive it on the sea.
They drove it on the sea?
Yeah, that's
Yeah.
what I said. Yeah.
Yeah, they
Take
drove
a
it on
drink.
the sea.
Bobby, come here.
Didn't hear it.
We're drinking. Oh, did he bark? Okay.
Yeah.
Oh.
Apparently going
Vela
crazy.
like Bella. Yeah, Vela. I don't know if it's pronounced Vela or I'm gonna assume it's pronounced Vela or Vela. I'm gonna go with Vela. Anyway, and so this Argo Navis constellation has been broken up into 3 pieces with Vela the sail, then you have Carina the keel, and Puppis. There's one right there. There's a Puppis right there. And we're talking about Puppis. And Puppis is also known as, take a guess. Anyone want to take a guess? Somebody wrote multiple pupils in our notes. So I'm going to guess that's Brandon that wrote that.
Brandon wrote
Do you know
that.
what it is? Do you know what Puppis is?
I do know what it is.
It's the poop deck. It's the poop deck, everybody. It's a constellation that's the poop deck. I wonder, did people actually go poop on the
Also
poop
the
deck?
stern.
Oh, yeah, okay. Well,
But I like the poop deck better.
the poop deck's fun. I'm sure there's a reason it was called the poop deck, and it has to do with poop. I'm just saying, there's got to be a reason. Brandon, do you know why the poop deck is called the poop deck?
That's where you throw the poop off the deck? Maybe you poop in the buckets and you go to the top to throw it off?
Yeah, that's what I'm going with. Okay, so Jack does Vela for the constellation, Vela for the star names. Oh, all right, there we go. Speaking of the stars in Vela, we have Gamma Velorum, the brightest star, binary star, and the binaries orbit each other in 78.5 days. And Mike has a smile on his face. I'm guessing
I just
you
have
found
the
out.
answer.
Yes, tell us the origins of poop deck, please.
All right. The poop deck is called that because the word poop comes from the French word la poupe, or P-O-U-P-E.
La poop.
La poupe, which means stern or back of the ship.
Oh, that's boring.
Oh man. Boo.
La
I'm just
poop
gonna
deck.
imagine that's where just people went poop back in the day. And then they had the crew come along and just pour buckets of water
Like
and have
hold their hands so they don't go off the back of the ship.
Yeah.
Like hold me fast, mateys.
Never let go.
Or if you don't like them, you just let them go.
So Gamma Velorum, this binary star system, it's one of them is a luminous blue star, so a very bright blue star that's 30 times more massive than our sun. The other star, however, is the closest and brightest Rayet star. And Wolf-Rayet stars, they're rare, and they're some of the hottest stars.
And they're wolves. They're made of wolves.
They're made of wolves. They howl
That's
in the
just
night.
science, guys. It's science.
No, this star in particular, this Wolf-Rayet star, is 170,000 times brighter.
Jesus Christ balls.
Than the sun, and its temperature is 57,000 degrees Kelvin. So our sun's surface temperature is like, what is it, 10,000 degrees?
Yeah, 10,000 degrees.
Yeah.
Ish. Fahrenheit, right?
So Fahrenheit. Yeah. Now, Wolf-Rayet stars, they can be between 20,000 degrees and 210,000 degrees Kelvin on the surface temperatures. So this one's kind of like in the...
So the sun's about, we're going to say about 7,000 Kelvin?
Yeah.
So this is much, much hotter.
Much hotter. Don't...
1 Kelvin equals 1 degree Celsius, which is about, what?
1 Kelvin equals 1 degree Celsius?
Yeah. They just have different starting points.
Oh, okay, because where the 0 is?
Yeah, so for Celsius, it's water. It's based on water. So where water freezes is 0. 100 is where it...
What happened with Fahrenheit? Was Fahrenheit just like,
So
what?
I actually found out about that. So Fahrenheit is 0 just because that's the coldest the guy could make his lab. So it was 0 because that's as cold as he can get it.
Wow.
Okay. I've always wondered about that.
Yeah, like what are we going on
Thanks,
here?
Mr. Fahrenheit.
And 0 for Kelvin is absolute 0.
Yeah.
You can't make your lab any colder than that.
No.
So.
Or can
Cool.
You can't. That we know of. No, you can't. Okay. The next star, Delta Velorum, is a triple or a quintuple star.
Okay, so we're not entirely sure.
We're not entirely sure. And it's made up of with some other stars in Vela and this star with another star in Vela and another star in Carina actually form a constellation known as the False Southern Cross or the False Cross. And so navigators, because there is
like a satanic cross.
I was thinking the same thing.
Yes, it's
That'd be a good drink name.
I should have read the notes.
So in the Southern Hemisphere, there's a Southern Cross constellation that's used for navigation because at the moment, there is no Southern Pole Star. Mm-hmm. So the Southern Cross is used for navigation. So the False Cross, made up of these other stars, has led navigators astray before. They've gotten it confused with these.
They're like the sirens.
They are. They're like the sirens, just fucking up people. And this star, I don't want to add an emoji.
So it's like the Sirens Cross. We should call it
the Sirens Cross. And this star, Delta Velorum, it's about 80 light years from Earth. And they're in the constellation of Vela. There are 7 star systems that have exoplanets that have been discovered so far. Most of them have Jupes or Jupes larger.
Jupes here.
There's one is definitely like
easier
a hot Jupes. And then there is one star system, planetary system, that has 2 super Earths.
Oh, cool.
So,
Hey, a
cool.
book I'm reading right now. One of the alien comes from super Earth. Yeah.
What book is this?
Is it a super alien?
What?
Is it a super alien?
It is super alien. Very strong little alien. Because
jazz hands.
I mean,
you guys will get that later.
Yeah. With multiple jazz hands.
Jazz hands.
Anyway, you'll have to read the book. It's a good book.
Okay. All right. Now, there's more than just stars in the area of the constellation. We got deep sky objects that are out there. One of them is the Southern Ring Nebula, NGC 3121, which is a planetary nebula. There's a ring nebula in the northern hemisphere, and this one looks similar to it.
What's special about it?
It's just there's a Southern Ring Nebula. And we know of the ring one in the northern hemisphere. So I was like, hey, why don't I point out there's also one in the southern hemisphere?
It's also one of James Webb's first pictures.
Oh, is it? Cool. So then you have the Gum Nebula, which I've never heard of. The Gum Nebula. It's a faint emission nebula, and it's possibly the remains of a 1,000,000-year-old supernova.
Oh shit! Really?
Yeah, that's like
that's pretty recent.
Okay,
Yeah.
so it's not a planetary nebula.
No.
It's the Gum Nebula.
So
does it look like gum?
I don't know. I didn't get any pictures of it. Inside the nebula, there's actually a smaller and younger supernova remnant inside this. So there's like, this is like an old million-year-old possibly supernova remnant, and then also inside of it, there's a supernova remnant as well. And this supernova could have been visible from Earth 10,000 years ago.
Oh, shit. Wow.
Yeah.
And what were we doing 10,000 years ago?
What were we doing 10,000
we
years
probably
ago?
were just like coming out of an ice age.
Hunting
well, the
and
Earth didn't
gathering.
exist 10,000 years ago, people.
Oh,
so.
that's right. I forgot. That's right. And it also has the first pulsar. Because at the center of the supernova remnant, it wasn't a big enough star for the core to collapse into a black hole or anything like that. So what remains is a pulsar that's basically just like these like jets that are like boo 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 because it's spinning really fast, and so energy's coming out, and it looks like a lighthouse if we're looking at it and we can see it. Anyway, it has the first pulsar to be discovered optically.
Oh, that's cool.
Yeah, I thought that was a neat fact. I was like, okay, that's cool. And then we have NGC 3201, which was discovered by a man named James Dunlop in
Sounds Scottish.
1826. It does a little bit.
Mm-hmm.
I would love to attempt to do a Scottish accent, but it's not going to happen.
Do everybody else's accent.
Scottish is hard. Scottish and Irish are really hard accents.
Yes, he was Scottish, and he worked in Australia, so get that accent down and hope for the best.
Scottish-Australian accent. It's a globular cluster, and it's one of two globular clusters that we found that show a definite inhomogeneous star population. So what this means is that the stars aren't all the same temperature or whatever, but instead the stars are hotter the farther away they are from the core. I know.
Because his belly done lapped over his belt.
Get in my belly.
Get in my belly. What is Brandon doing?
I don't remember what this was for, but apparently I need to watch the movie again.
Gold.
Yeah, it's
Austin Powers Gold.
Gold member.
Gold member. Yeah, because I was like, because James Bond movies also just sound like they should be parodies as well. So.
So I think the last episode I talked about me watching GoldenEye again, and then after that, ended up watching The World Is Not Enough, and it just gets better and better. Oh my god, it's so gloriously good.
Good.
Yes.
It's bad but good. Yeah, I get it. So globular clusters should most of them we see the stars are the same population, same type. They're in the same phase. They're all kind of like together.
Phase of life.
Phase of life. But this one has not stars that are not the same within it. So. We found two of those, apparently. It also has, this will be the last deep space object that I'm highlighting in Vela, RCW36, which is not a race car.
Such a romantic name.
It's a star-forming region. It's the nearest star-forming region to Earth, and it produces a cluster of hundreds of young stars.
Come here.
So it's just a little area.
It makes how many? Because Brandon was talking.
I just said produces a cluster of hundreds of young stars.
Oh, okay. So it makes a lot of stars.
So it's just making stars. I just thought that was neat.
Mr. Frodo just needs to be right there to rest of the.
He's pod.
No, every time he barks, he jumps on me. So that's how you know he barks.
Oh, well, you know what? Maybe if we don't hear it, we don't take a drink. He's so damn cute. I love him.
If we don't hear it, we don't take a drink.
Yeah.
So if we hear it, we take a drink.
Okay.
Now, remember I mentioned that Vela was part of a single constellation before, and it was broken apart. So there is no actual mythology for Vela other than it was part of the ship that Jason and the Argonauts.
Why didn't we break it apart? Were we just bored and just wanted to add two more constellations?
Well, it was this. So the constellation was made or whatever, and then it was most accurately charted in 1752 by a French astronomer named Nicolas Louis Delisle. I don't know.
He's not alive.
He's
not gonna.
I don't know how to do French.
To.
And so that is actually when the Argo Navis was divided into three.
All right, well, Jack says too big. I don't know if that's a statement or a question.
That the constellation was just too big. That's we can break this shit up. I guess
there was
sense.
There was a Teddy Roosevelt astronomer. We had to break it up. Break up the anyway.
You had to walk softly and carry a big stick on that constellation. Is that
too?
Is that a Roosevelt reference? I don't know.
Yeah, that's Roosevelt. That the man in the arena. But his whole thing was breaking up monopolies, so he was the buster.
Oh yeah. See, my American history is
We need
a
more.
little shaky.
We
But
need more
we started watching the
busters of
American
Monopoly.
Revolution documentary
Yes,
by
it's
Ken
so good.
Burns.
It's so good.
Yeah, it's good shit. I'm enjoying it. We also watched the Death by Lightning on Netflix about James Garfield.
Oh, me too. That was so good too.
So good.
I wasn't expecting it to be good, but lo and behold,
Me
it
neither.
had my attention the whole time.
Me neither. I was really interested.
For more on this, check out the.
Find us in the Hangover. Find us in the Hangover. All right. All right. Now, the sky, there's more to the night sky, of course, than a constellation up there. So, for December of... okay. So, Jack says it was too big. After the river, it was broken into balance, the northern and southern constellations. All right. That makes sense.
All right. Yeah,
They're
sure.
Like, all right. Let's break this up. Plus, it's easier to, like, chart out shit that's in the sky, in smaller chunks. Anyway,
Yeah.
Hey, all right. So December, we have some planets that are going to be up that you can view. In fact, Mercury. It's a good time to see Mercury on December 7th. It's at its greatest western elongation. So
if you're not in Oak Ridge.
So if you have not a lot of...
no, we actually could have a shot.
Maybe? If you don't have a lot on your horizon, then it'll be a good time to see Mercury. Mercury tends to stick close to the sun, being the closest planet to the sun in our solar system. And so on December 7th, it's going to have its farthest, kind of distance from the sun. And so it has a better separation from it in the sky from our point of view. And so it's kind of the best time to try and spot the little guy. Mars, unfortunately, sets with the sun. Venus rises with the sun, so no go on Mars and Venus in December. But Jupiter rises 2 hours after sunset, and Saturn will be up there for the most of your awake time of the night because it sets around midnight. So unless you're staying up into the wee hours of the morning, you can see Saturn until about midnight or so. So
okay.
What do vampires do during Christmas? Do they have a...
Is this a riddle, or
do they celebrate Christmas?
Everything I say is technically a riddle.
Do they give each other presents?
I don't know. I thought Liz would know that.
What is the...
It's...
What holidays do vampires have is what I'm asking. What do they celebrate?
They celebrate Halloween. We all celebrate this one.
Halloween. They probably like Valentine's Day.
Oh, that's true. All the hearts.
A lot of necking.
Hey.
All right. All right, now.
There you go.
Hey, there we go. Great Elizabeth minds think alike. So as far as some celestial events going on in December, on December 4th, we have the full moon. It is the last of I think it was 3 supermoons this year. And so that just means the moon's slightly closer and it looks a little bit bigger, but it's really not gonna be that noticeable with your own eyeballs. But hey, check it out, because the moon is always super. It's known as the cold moon, because it's December and things get a little bit chilly.
For, at least us up here in the north.
At least in the northern hemisphere, it gets a little chilly. And most of these full moon names, I don't know if in the southern hemisphere or if any indigenous populations in the southern hemisphere have names for their moons, but most of ours that we know of are derived from Native American tribes.
Yeah. It's very North American, northern hemisphere centric.
Yeah. But it's a cold moon in December, so December 4th. And also, it is going to occult the Pleiades. So, if you got binoculars, you can watch the moon basically cover up the 7 sisters, the Pleiades.
And then uncover it. And it's going to take a bit, so just...
grab a blanket, get some hot cocoa or a hot toddy.
That sounds nice, actually. I want to do that.
And a chair that leans back.
Elizabeth, do you think the Maori tribes have 30-letter names for the moon seasons?
Okay, I would hope so. And we should use those.
Okay.
We need more Maori.
We do need more Maori stuff. Are we allowed to do that? I don't know.
We are not allowed to do that. But yeah.
Okay. And of course, the main event in December is December 21st. The winter solstice!
Woo!
Oh, I thought you were going to say my son Alan's birthday.
There are 2 main events.
So 21st, the winter solstice. So that is when winter begins officially. We'll have the shortest day and the shortest night. No, shortest day and longest
Shortest day.
There we go.
night. Shortest day and longest
Yeah,
night.
it's like a whole Pitch Black episode.
When I was telling my parents this today when I talked to them on the phone, when I was in Poland, Łódź, Poland, but
Where you get a
spelled
little
Lodz. I would walk to the class, and at like 7:30 in the morning, 8 o'clock, it's dark.
Gosh, that's weird. That's late. So late for it to be dark.
Teach the class, leave at like 4:30, 5 o'clock, dark. Somewhere in between, the sun apparently
came out?
was up, but yeah, the sun set at 3:30.
That's
Wild. It was crazy.
yeah, that's weird.
It's because it's even further north
I
than
know
we are.
you don't even think about that. You think that is relegated to like the North Pole or Antarctica. You know, like you don't think about. Anyway, that's cool.
Earth's round, man. It's crazy.
No,
I mean, I
don't
enjoyed
like
it,
that.
but
Explain that,
it was
flat earthers. Anyway, we have Meteor Shower Watch 2025. December 13th and 14th is one of the best meteor shower shows of the year. The
Hell yeah.
Geminids.
Hey.
You can have up to 120 meteors per hour.
We might be able to see that here if it's not cloudy.
That's the key point, if it's not cloudy. But it's going to be a thin crescent moon, so that's good viewing moon conditions. You can only have better moon viewing conditions if it's a new moon, which... Hang on to your boots, everybody. But this meteor shower, the Geminids, comes actually from an asteroid. Asteroid 3200 Phaethon, discovered in 1982.
Oh, okay. Used to be a comet, though.
Mm-hmm.
It's the only way that you can get the meteor shower. So basically,
It's a zombie comet.
It lost all its stuff, and now it's an
It lost
asteroid.
all its fuzz and stuff, all its ices.
All its icy
And now
stuff.
it's just
Yeah.
rocky.
Now it's just a rocky
Boring,
husk
rocky.
of its former self.
Oh.
Speaking of Hail Mary, heyo.
Okay, so we have one more meteor shower. Not
Wait a
as-
minute, Geminis. I just want to say, best time to see a meteor shower after midnight. I'm going to say this every single time because the Earth is turning into the stream, and it's just the best time to see it. So go out. Then you really do not have to worry about the thin crescent of the moon. It's a long set. So go out, enjoy it.
Now
120
grab a
meters.
blanket
Watch-
and a hot
Definitely
And
chocolate.
watch the Earth cross
blanket.
the stream.
And
Don't
damn
cross
it,
the streams.
I'm not even going to be here for it.
Oh, I guess it'll be me and the dogs going out and trying to look at some Geminis.
I hate work.
I'm sorry. But it pays for this house. We also have on the winter solstice and the winter solstice +1, so December 21st and December 22nd, the Ursid meteor shower. This is a minor show, 5 to 10 meteors per hour typically.
Okay, it's cute.
Oh, but that's gonna be high up.
But-
No, it's gonna be low.
But it's a new moon, so there's no moon whatsoever, which is the best moon viewing conditions you can have. And this meteor shower comes from Comet Tuttle, discovered in 1790.
Go ahead.
No. Go ahead.
I was just gonna say it feels like every meteor shower comes from Comet
No,
Tuttle
this
or
isn't-
Swift Tuttle
This isn't Temple Tuttle.
or Temple
just
Tuttle
regular Tuttle.
or
Just Tuttle by itself.
Haley's got
Alone
two.
Tuttle.
Like
I guess
the
the-
most famous comet in all of like history is like, to hell with all these other comets. I'm gonna be responsible for 2 meteor showers.
Yeah, the
on
best
Earth.
meteor shower comes from a fucking asteroid. That is a
That's
former
true.
comet.
The other great one is the Perseids in August.
Mm-hmm.
Yeah. Huh. So there you go. There's a night sky for December. Some things to check out, some things to look forward to. Otherwise, as always, just in fact, last night I wasn't expecting it to be clear for some reason. I just thought there would be clouds, and I go outside to let the dogs out to go potty before we go to bed. And I looked up and I was like, "Oh shit, it's clear!" And so I turned off our fence lights, and I was just like, look at that." And then I went inside because it was cold.
I gotta say, just before we get into the news, it doesn't matter if you have a telescope. It doesn't matter if you
As long
know
as
what the
you
night
have
sky
eyeballs,
is.
I guess.
Just go out, enjoy the night sky.
Yeah.
It like
And-
calms you, and it also makes you feel like you're part of something larger. And
You are
it's
the
just
Earth.
really, the stars are beautiful
And
to
the
look at.
universe.
They have and the northern hemisphere with in the wintertime. So
Oh
this time of
yes.
year, the colors that we have for these stars, the brightness, most of the brightest stars are in the wintertime. You have the biggest like variation in colors, and it's just beautiful. And if you're living in a little city like Phoenix or somewhere else
New
or
York
Portland,
City.
yeah, little tiny places like Beaverton and Phoenix that don't have a lot of people, but for whatever reason have a lot of street lights, then maybe go out, get away, and interesting date night. Go out and just enjoy the stars.
Into the darkness all alone. Great first
Yeah.
dates.
All right, maybe wait till the second date.
Yeah, yeah. Meanwhile, Jack in Chat is posting Hawaiian moon phases.
Oh my goodness.
Names for those.
Seems to be quite a few.
And I'm not going to read that.
Nope.
And,
Nope.
Although
Nope.
I understand Hawaiian pronunciation, you pronounce every
letter.
Every letter you pronounce.
O is oo.
Every
Right?
3
No.
days gets a new name.
Mahalo.
Oh, wow.
No, O is O. A is A. E is A.
like
Hawaii.
Hooked on
E.
phonics monkey.
Yeah. I is E. So yeah, but you pronounce every single letter.
Yeah.
And every syllable ends in a vowel. That's as far as I'm gonna go.
It is a fun language. I like listening to it. I like hearing it. Anyway, astronomy news. We get some astronomy news. I saw some cool articles. In fact, there's one thing in here that I
There's
decided
no
to...
sound effect.
Because we already did that for the media shower watch. I didn't
But
want
do
to
it again.
double over it.
News.
No, do it again. We can
Astronomy
edit it in
news.
post if we don't want it. Do it.
I'm not going to edit it and post. I'm too lazy for that. Astronomy news 2025. Although check out our
Thank you for
tardigrades
humoring
episode
me.
because I did add the special effect into the tardigrade episode with the echo that we were doing.
Oh shit! Really? Oh, that's
Yeah,
great.
yeah. Oh, I'm glad that Katie did the sound effect to herself. See, look, people at this point can just do the sound effects. Like when we're going back in time. How many people did it in their heads right now? Anyway,
We should just do like an entire show of just sound effects. We just
Oh
grab.
God.
It's just
We have a very small audience as it is. We would lose everybody after that.
like goodbye. All right. I feel like I got a couple of James Webb stuff in here because James Webb is killing it. It's killing it in observations and science. So James Webb Space Telescope spots a gassy baby galaxy throwing a
I almost
tantrum
named
in the early universe.
Gassy baby.
Gassy baby. That would have been.
Yeah, see, baby.
That would have been fun. This article comes from space.com. This galaxy is it's a bright young galaxy from the early universe. It's among the first generation of galaxies, not the oldest, but among the first gen. And it was born when the universe was less than 500 million years old. So, pretty young.
Pretty young, yeah.
Pretty young. It's this galaxy is called SXDF-NB1006-2.
Hell yeah.
So there you go. And we're basically seeing the galaxy as it was when it was 1 to 2 million years old. And this galaxy is forming stars at a rate of about 165 solar masses per year.
Okay, 165
So-
sun-like stars every year.
But how is that relative to other galaxies at same age?
It has 16 times, well, I don't know about the same age, but as far as our galaxy, it has 16 times the star formation rate of our own galaxy.
So
That
there you
makes
go.
sense.
So it's
Well, no,
poppin'.
is that current? As current?
As well, current, yeah.
Well,
Yeah, so that makes more sense.
yeah,
Yeah.
that makes more sense that 500 million. It's a young baby galaxy.
Yeah.
Really
It's popping out those stars.
popping out stars.
Popping out stars.
Is it?
It's popping out
It's-
stars
It's
like
weird though
teenagers
that a
popping
baby
pickles.
galaxy is popping out stars.
Well,
It's a little weird.
I mean, their stars are being born in the galaxy.
Don't
so
don't
it's
don't we
popping
don't
out.
we don't need to add human characteristics to galaxies in this situation here.
All right, so basically at this rate, the galaxy is producing a lot of large, bright stars. And so these stars are going to do one of two things. Either
Okay.
they are, and they also have like tremendous outflows of particles like solar wind.
Gassy.
So the gassy, and they die.
But what do they? Okay.
They
What do they
die a
do?
lot.
You
And-
said they had to do two things.
Yeah,
Two
the two
things.
things. I'm sorry. The two things are
They
they're real
gassy and they
gassy.
die?
They're gassy. They're gassy. They're just real gassy, and then they die a lot. They explode as big supernovas almost as soon as they're born.
Oh,
They're that big,
okay.
that big
okay,
and large,
So
and
like this is on the very high end of math.
high end. Yeah, so they're like
Mass
born,
limits.
and then they're just like, they explode.
Okay.
And so this causes huge plumes of gas to basically flow out of the galaxy at 310 miles per second.
Okay.
Fast.
Okay.
It's fast, which is 3 times faster than the escape velocity of the galaxy, meaning that gas ain't coming back.
No.
It's going out.
So it's heading this way.
It could be.
My God's coming right for us.
It's going everywhere, right? It's going in all directions from
It's
that
going in all
galaxy.
directions, so it's heading this way.
Now, what's kind of pretty unique or interesting about this particular galaxy is that there are more heavy elements in the galaxy than there should be given the ages of the stars. So that means there actually must be older stars that are behind the newer stars that we're not able to see or resolve. Well, we can't resolve the individual stars anyway. It's too fucking far away of a galaxy as it is. But there must be older stars there that have already expelled those or are creating those gases or elements or whatever. Now, this galaxy, because of the rate of star formation, it's going to basically run out of gas in a few hundred million years.
So it's
So it's
already
already
gone.
dead. It's already
gone.
It's already
Well,
not active anymore.
This is
It's
like
already
when you
No,
look. Go ahead.
Hold on. I think we need to clarify this. The galaxy is still there.
It's still there. It's just not star formation.
Star formation is done.
So it's already depleted itself by in our current time frame. But we're seeing it when it was just ripping and roaring through its gas.
We're making shit. We're living this good life.
We're seeing it in its prime.
Yeah.
And now it's just a quiet husk of itself.
They turn 56 and get old, and it all stops.
Just ran out of gas. You
Nothing
just run
works.
out of gas.
Yeah. Nothing works anymore.
Now this next article, this one's for you, fancy physics man.
I already read it.
Here we. Oh, you already read
I
it.
already read it.
Okay, the galaxy's gone through menopause. It's already gone through menopause. Are astronomers wrong about dark energy? New study casts doubt on universe's accelerating expansion.
All
This is
right.
from CNN.
Let's hear it.
All right. So the universe may not be expanding, but it may be slowing down in its expansion.
Okay. The
What's
universe
going on
might
there?
not be accelerating,
but slowing down.
which actually is an acceleration. It's a negative acceleration. But all right, go ahead.
All right, listen here, Mike.
Jesus. All right. So currently we have a pretty limited understanding of dark energy. Isn't that right?
That's why it's called dark
No,
energy.
we do not have a good understanding
Yes.
of dark energy.
We have a limited understanding.
We have very limited understanding. Did you say we? Oh, I gotta move this off my ear. Did you say we had a good understanding?
No, I said
oh.
we have a limited
Oh,
understanding.
limited. Yes, we have a very limited
Yes,
understanding.
Yes. Okay. All right. So a consortium of hundreds of researchers that use data from the Dark Energy Spectroscopic Instrument, or DESI, in Arizona, they developed the largest ever 3D map of the universe.
You know who also helps with that?
Our buddy of the show, Ron Proctor.
Ron
Check out the
Proctor.
MrProctorShow.com. So what they're finding is that dark energy may actually be weakening over time, which means it's changing. It's subject to change.
Mm-hmm.
And this means that the universe's rate of expansion could eventually slow. And what the researchers did was they analyzed a sample of 300 galaxies that had Type 1a supernovae. Type 1a supernovae tend to be known as standard candles. So they're a good way to just measure shit in the universe, basically.
And that is when, correct me if I'm wrong, but I think it is when a white dwarf pulls material off.
Yes.
And so the reason why it's a good candle, standard candle, is that they always go boom at the same time.
In the same way.
Same brightness.
Yes. So you have a white dwarf, which is like a dead sun-like star, basically, that has a companion star, and it's pulling material from that companion, pulls too much material, and then it eventually goes boom.
Right. And so that material falls onto the white dwarf. It heats up to a certain temperature, and that is a runaway boom that ends up happening. Mm-hmm. And it always happens at the same temperature. So continue, because having not the degrees that these people have, I do have a question or a comment.
Okay. Well, according to Junhyuk Sun, who's a study co-author, he said, before our work, Type 1a supernovae were thought to explode with nearly identical intrinsic brightness, making them highly reliable standard candles. However, we found that their luminosity actually depends on the age of the stars that produce them. Younger progenitors yield slightly dimmer supernovae, while older ones are brighter.
And this is not the first time that a group has questioned whether a standard candle is actually standard. This happens fairly often, but it seems like these guys actually have some data to back it up.
It seems so. Now, if the expansion continues to slow down, the universe could begin to contract, ending in what is known as the Big Crunch.
Yep.
Taco Bell, come see me. I got an idea for a new entree.
Which is kind of fun to think about. Now, the lead researcher, his name is Young Wook Lee. He's a professor of astrophysics at Yonsei University in South Korea. And he said that it is a possibility. Even 2 years ago, the Big Crunch was out of the question, but we need more work to see whether it could actually happen.
Okay.
Here's where we have the great physicist fight.
Physicist fight. A clash of the physicists.
That was my, whatever that basketball sound is, or horn. That was my impression of that. That was a better
Okay.
one. That was a better one.
Okay.
All right. So, according to Adam Rees, or Rise, a professor of physics and astronomy at the Johns Hopkins University, and one of the recipients of the 2011 Nobel Prize in Physics, said, this study rests on a flawed premise. It suggests supernovae have aged with the universe, yet observations show the opposite. Today's supernovae occur where young stars form. The same idea was proposed years ago and refuted then, and there appears to be nothing new in this version.
He just sounds like a cranky old white man, I assume, right?
I mean, he probably is.
Yeah, but
So what?
But he has some shit that backs up what he's saying.
Now,
Oh, sure. I know. Yeah, I know nothing about him.
Lee comes back at that comment, and he says that Reese's claim is incorrect. Even in the present-day universe, Type 1a supernova are found just as frequently in old quiescent elliptical galaxies as in young star-forming one, which clearly shows that this comment is mistaken. Boom. Cranky old white Nobel winner. The so-called paper that refuted our earlier result relied on deeply flawed data with enormous uncertainties, he said, adding that the age brightness correlation has been independently confirmed by two separate teams in the United States and China.
They're throwing shade. So the so-called paper that's in the quote. Oh, it's wild.
I love it. I love it. So basically what this shows is that, okay, in the past you had some people that were like, hey, guys, I think there's like these tiny little particles we can't see and let's call them quantum. And then other physicists were like, you guys are fucking crazy. You're full of shit. There's no fucking way in your so-called papers that there are these little tiny fucking quarks and whatever. So it just shows that, that physics and our understanding of the universe really, like, it's not down to a science. I mean, we don't...
I mean, technically it is down to a science.
A science, but we don't have all of the science to, we're still trying to understand. We don't know everything.
We don't have all... Well, it's true we don't have all the science.
To say everything.
I think for this, we do have the science. We just don't have the data. Now, for the dude in Korea... Now, I'm not saying he's wrong.
Mm-hmm.
I do not have the chops to be able to say that he's wrong at all, and I will never say that. My only question is, what is the physics? Because it to me, the way that the this is popular science, right?
Reading Jack says, I'm visualizing nerds in Andre the Giant singlets with pocket protectors built in entering the ring. Yes. Let's have these debates in the wrestling ring. Special night of WWE.
Oh, that would
Monday
be
Night
awesome.
Raw.
I prefer epic rap battles of history.
That shit's good too.
Would Adam watch that? But anyway,
Yes.
that is all right. So I guess, how does a white dwarf, that is accreting, is this material is falling onto it? How does the physics know that? And I do have a thought on this, but how does the physics know that this is a young star versus an old star? The physics is a physics. There is no.
Maybe it has to do with the amount of gas or some shit.
I mean, that's a thought. Is that as material is falling onto it, you're getting a higher amount of, say, like helium and other elements and stuff like that. But in all honesty,
I think because they're using the luminosity to do measurements with dark energy, I think it's not they've noticed different, that the luminosity isn't as standard as once thought, maybe.
Yeah.
I don't know. This just feels.
Look, I don't know.
But I do want to point out, this is exactly how science is supposed to work. Here's a theory.
No, exactly.
Let's poke holes in it left and right and
Yes.
make sure people can cover it up and explain it away. If not, it's wrong. So this is exactly how science is supposed to work.
I follow the fucking data. Whatever the data says.
Not lore.
Is whatever the.
Lore. Never follow lore.
No.
Unless it's to your death.
Whatever the data says, that is what it is. Kill your darlings. Do not hold steadfast to old ideas. And if there really is a time dependency, an age dependency on these type 1 supernovae, then now we kind of have, I'm not going to say a problem, but it does give kind of a range for some of these things. And it might get rid of dark energy, which actually makes the universe simpler. And I'm kind of cool with that in a way.
Are you saying that with all this, different ranges of times, we have a wrinkle in time?
I think that's a little forced, but okay.
Everything I say is forced, Mike. Welcome to the show.
Time reference. Now, okay, everybody, Vera C. Rubin might hold everybody's beers, because the Vera C. Rubin Observatory started working this year. It's set to help settle this debate with the early 2026 launch of the Legacy Survey of Space and Time, which, by the way, Legacy Survey of Space and Time, that sounds
legit.
That sounds like a great show,
sounds
actually.
Amazing, yeah.
I would watch that show.
So we're going to be able to peer deeper, farther, faster, better, whatever Daft Punk quote, with the
Is that Daft Punk? It sounds like a very NASA pro.
That faster, murder, better, deeper, faster, fun,
stronger.
But didn't that originally
I don't know.
start with like NASA, like how we're gonna go to like Mars and stuff, or how they were?
That's faster, cheaper, better. That was in the '90s under Administrator Sean something or another. Anyway.
And there's Brandon with the random NASA fact from age-old history.
I knew Brandon would know.
I knew he would know. Stuff. So we'll see. So there's been some new studies that say one thing, and old Nobel Prize winners are like, fuck you guys, you don't know what you're talking about. And then we got new telescopes that'll be like, wait, let us take another look at some stuff.
I do love the idea of a Nobel Prize laureate being proven wrong.
I just want to see some physicists duke it out in the ring now. I think that
would be great.
That'd be really funny. There we go. Harder, better, faster, stronger. There we go. Thank you, Adam.
Who is?
It's Adam.
Orange Jack? He changes?
I think everybody's things except for Jack are weird on here. Anyway. All right. Next one. Now, this is something that I wanted to highlight on the last High in the Sky for November, but I was lazy and didn't get any pictures together.
No. Lazy means no. There's no lazy. You are more efficient. you work more efficiently. In this particular case, you wanted to give our fans
I was
around the
lazy.
world.
So this time I wasn't as lazy. So this dying star is forming a strange spider structure, and web is giving scientists a brand new view. This is the Red Spider Nebula, and I have, an image right here.
Oh, that's pretty.
Ooh.
I think it's just absolutely gorgeous.
I was gonna say, this like ooh and ah sounds like sarcastic.
But
it's not.
It's not.
This is like very.
This
very
is the
beautiful.
Red Spider Nebula, NGC 6537, and I really just wanted
Are
to.
you okay?
Yeah,
It's
it's
a
fine.
spider.
No, it's a pretty spider, so it's fine.
Not
and
in the
it's
house.
not here. And I just really just want to show it because it's just a really cool fucking picture, and that's really why I wanted to show it. And I was gonna put it in the Hubble version as well to do a comparison. I forgot about that. But the lobes are bubble-like structures that each stretch about 3 light years across. The light is emitted from H2 molecules. Gas flowing from the center of the nebula has inflated the bubbles over thousands of years. And the purple kind of S shape at the heart, which I don't know if you can really tell in this image of that.
I can see it.
It's light from ionized iron atoms.
Oh shit! Interesting.
Yeah, so I thought that was neat.
Have we done a show on how we color?
Yeah, well, we've
images?
talked about it. Yeah,
I think we have a
Yeah.
while ago.
Yeah, we
that
have.
I think maybe in the episode we talked about corn dogs for a while. I don't remember.
Oh, it might have been. No, that was with that Shannon from.
I would love a corn dog actually.
Oh God, we were talking about corn dogs the other day, or hot dogs or something. Anyway, so that was the Red Spider Nebula, and I just wanted to show the new. It's just a cool James Webb picture of it because I thought it was. Really
I know that like everybody at any point in history says the same thing.
They want corn dogs.
Exactly, as they should. But fuck, do we live in an amazing
because we get
time?
corn dogs.
Because we have corn dogs, but because we have like the James Webb Space Telescope,
It was
the Hubble Space Telescope.
One might say it was the best of times. It was the worst of times.
The worst of times.
Oh shit! What
Two-handed
are
Korean corn dogs.
What are these?
What are Korean corn dogs?
Oh my god, Korean corn dogs are the absolute best. So in the middle between Seoul and Gwangju, South Korea, we stopped at this little truck stop, right? And there's like multiple shops of just different types of corn dogs. Some are just pure cheese with different seasonings. Some has a giant meat in them filled with cheese. Others, there's lots of cheese in these corn dogs. They're incredible.
We gotta go to Korea, South Korea, not North one.
No,
It's just the South
I'm
one.
not going to North. But
Although it is weird when you fly into Seoul or go to the airport, you can see North Korea across the river.
Oh,
And it's
yeah.
weird being in this magnificent city and looking across the way and just seeing nothing. Like it's eerie.
That's
yeah, I really think about that every single time that like I fly to China or like that I end
wait.
up.
I'm sorry, but Elizabeth says they have them here now. We can get Korean corn dogs here. We gotta look. They gotta have them in Portland somewhere.
Cup
I'm
Pop
sure.
doesn't count.
Cup Pop.
Anyway,
Cup Pop.
so for more on South Korea and Cup Pop and the corn dogs, check out the
check out
Hangover.
The Hangover when we forget that we were going to talk about this. Okay, the next article is scientists get a first look at the innermost region of a white dwarf system.
Cool. Let's see it.
Okay, so I do have an image. This system is 200 light years from Earth, and it's just an artist rendition.
Oh.
It's not the actual. I'm sorry to disappoint you. All right, but this is also when we were talking about the Type 1A supernova.
It looks like Laffy Taffy or whatever it
does.
is.
That looks like the Rainbow Road from Mario Kart.
It's a simple Rainbow Road.
Yeah. I'm good with that.
But so you have the white dwarf that's in the center. It's pulling that material from the large star due to its powerful magnetic field. This system gives off intense radiation from the gas falling onto the white dwarf from the larger star. The X-ray polarimetry explorer, or IXPE, it was used for this research. The lead study author is Sean Gunderson, a postdoc in MIT's Kavli Institute for Astrophysics and Space Research. And because there's a high degree of X-ray polarization, this is why they use this telescope. The X-rays were emitted from a column of white-hot material that the white dwarf was pulling in from its companion. And these columns are being emitted 2,000 miles high, which is half the radius of the white dwarf. And the X-rays are reflected off the white dwarf's surface before scattering into space, which is an effect that physicists have suspected but haven't confirmed until now.
It's always good to have that proof. All right, hold on. Are we done? Oh, there's more.
Well, there's just one thing.
Okay, hold on. So, Katie and Adam, I'm now talking directly to you. We have been to your place, and you are now just telling us that there is a Korean place where I can get Korean-style corn dogs.
Glorious.
We're gonna need to talk when you come here on Tuesday. Cheers.
Anyway, this is Liz talking to the rest of you now. This basically just demonstrates that X-ray polarimetry.
Okay.
I don't know.
What does your heart tell you?
Can be an effective way to study these extreme
we gotta take a drink. What does your heart tell you?
Damn it! I thought I could sneak that one in under the radar.
Which
Is Frodo alive? What does your heart tell you?
Yes.
Yes, he is.
Yes,
alive.
he's alive.
Yes.
That's one of the things I quote the most from the movie, I think, is what does your heart tell you?
I guess that's true. Now this one's pretty cool. This is also James Webb. Webb reveals APEPs. Well,
what?
APEPs, yeah, we'll talk about APEP.
Oh.
APEPs, 4 spiraling dust shells shaped by Wolf-Rayet stars.
Hey!
We talked about a Wolf-Rayet star in Vela, so I thought
Stars
this was
made of wolves.
appropriate. Here it is. This is the image of the spiraling dust here.
All right, this is actual image.
This is an actual image. This is not a an artist impression. There's 3 bright stars that are a part of this system, basically. But so this is a mid-infrared image of a system of 4 serpentine spirals of dust, one expanding beyond the next in precisely the same pattern, as you can see here. Yunuo Han, the lead author of this paper, which was published in the Astrophysical Journal, and he's a postdoctoral researcher at Caltech in Pasadena. So there were observations that were taken prior to Webb that only detected like one shell around this star, and the existence of other shells was hypothetical until now. Webb has provided the visual evidence that there are the more shells surrounding it, and these shells are emitted over the last 700 years by 2 aging Wolf-Rayet stars in a system known as APEP. That's right, APEP. It's fun to say, APEP. Which is actually...
You gotta pop your P's.
Which APEP is the Egyptian god of chaos.
Oh hell yeah.
Okay,
I got a new nickname for Frodo.
Yeah.
Speaking of which.
That is a good one.
All right, that's well named. All right, cool.
So these have a rare orbital. The 2 of the stars pass by each other every 190 years, and they pass closely for 25 years, and they form the dust, which is what's forming these shells. It's a rare orbital period because most Wolf-Rayet binaries have orbits between 2 and 10 years. And so they have confirmed that there are actually 3 stars that are gravitationally bound to one another in this system. So you can actually see them in this image, the bright ones. So there's one in the lower bottom, almost mid, but kind of right middle. And then the bottom left, and then the one in the middle of the spiral. Those are the 3 stars that are gravitationally bound. Yes, no one can see you point at them in the picture.
No,
it was for yourself.
I was really kind of hoping that you would actually be a little quieter about it, like with a little
that
nod
I wouldn't
or
point it out that you were pointing to the stars to
yourself.
But
I thought about doing the same. I thought about like running a mouse over, like, see here and here. Of course they can't. What am I talking about? This is a podcast, not a watchcast.
Use your imagination. Although the video is now in Spotify.
Oh, don't say use your imagination.
Use your imagination. Now, dust that's ejected by 2 of these stars is actually slashed by the 3rd star, which is a massive supergiant star, and that is actually carving the holes that are in
that's
this image. So
cool.
the third stars has caused these holes that are in here. And basically these are whipping through space and sending out dust at 1,200 to 2,000 miles per second.
That's pretty quick.
Pretty fast. Now the dust itself, it's largely amorphous carbon. I don't know what that means.
Amorphous carbon.
Amorphous carbon.
I'm gonna
Let's
go
break
out
it
on a
down.
limb and say it's carbon.
It's amorphous
What?
carbon. So according to Han, the lead author, carbon dust grains retain a higher temperature even as they coast far away from the star. While the exceptionally tiny grains are considered warm in space, the light they emit is also extremely faint, which is why it can only be detected from space by Webb's mid-infrared instrument, or MIRI. So, and that's why ground-based telescopes haven't been able to see the shells. They're basically too faint to see. What does amorphous mean?
All right. Well, this comes to you from Google AI.
So take it with a
amorphous-
grain of amorphous carbon,
Yeah.
if you will.
Amorphous carbon is a non-crystalline form of carbon that lacks long-range ordered atomic structure. Unlike it's not like graphite or diamonds.
So
It has a disordered glassy structure with a mix of something called sp2 and sp3. Hydrized carbon bonds.
So it's not structured.
It's not structured.
It's not
I think
structured.
basically is
All right, it's amorphous.
Mm-hmm.
I also thought when I heard that word, I just thought of like frogs because amphibians.
and like
Okay.
amphibian carbon.
It's amphibian carbon.
That's great.
All right, so the remaining mystery in this is the actual precise distance to the stars from Earth. We actually don't know how far away they are from the Earth, and that will require future observations. And eventually, all the stars will explode, and either one of them could become a black hole.
Oh, my favorite thing in the universe.
I know, so I just think
other
that's
than
fun.
you.
So basically, Webb has scientists were like, hey, here's something here. We know that there's this one thing here. What is happening here? We know there's one thing going on here. We think that there should be other stuff going on here. And then Webb comes around and they go, hey, we were right. There's the things we thought that we thought was there, and it's actually there. And Webb proved some science. Science was proven.
I think Webb's going to prove a lot of science. It's also going to upend a lot of science.
Yeah, a lot of physicists.
That's the hope.
All right,
A lot of physicists
it's
are
going
gonna
to
be
prove
fighting.
a lot of things that we might understand. It's going to upend a lot of things that we thought we understood.
Which is good.
Science
Well,
is science,
that's what we
right?
want.
So-
Science gonna science.
Science is going to
Science
science.
gonna science.
Or was it Science Be Wild?
Science be wild.
That's be wild.
Science be wild and science gonna science. All right, last one. Last article.
Oh, I thought that was the last one. All right.
No, this is the last one.
There's always more in space.
There's always more in space, where no one can hear you scream. And this covers one of my favorite space topics. And the title is.
Oh, yeah.
And the gimme gimmies. The Andromeda Galaxy quenches its satellite galaxies long before they fall in. So,
Ooh.
folks, we're talking about galactic cannibalism.
Hell yeah, we are.
And by the way, it's me first and give me.
I don't care. I'm just... Look, this is how my... I'm sorry. Did you write this or did Brandon write this?
Mike said it. I just have to fill in the gaps.
This note in the outline says, Mike loves black holes more than Jackie.
No,
He said it.
I did say it, actually.
You did?
I did say it. I said other
And
than you.
my mind said, A, that's sweet. But B, wait a minute.
Jackie.
We're missing some folks
no
here.
No one loves anything more in the universe than Jackie.
Yeah, I actually love Jackie more than Liz. Yeah.
That's fair. That's fair. Okay, so we all know I love galactic cannibalism. Larger galaxies gobbling up smaller galaxies. It's good times. And mergers of galaxies, they play a big role in galactic growth. So our Milky Way slowly consuming the large and small Magellanic Clouds in the southern
And
hemisphere.
others, yeah.
Just slowly sipping on them over time. Just
Sipping
taking
on
a little, taking little nibbles
sipping.
here and there, you know.
Is it a sip or a nibble?
It's either or. It depends. They sip
It's
in
a
the gas and
galactic
nibble in the
gulp.
stars.
Okay, that's fair. That's fair.
And actually the evidence of this is there is a stream of gas called the Magellanic Stream that's about 600,000 light years long that is coming into the Milky Way because it's like it's slurping.
It's slurping.
I drink
Slurping.
your galaxy.
So our neighbor Andromeda, which is a bigger galaxy than us and also headed our way, stay tuned for more on that in about 2.5 billion years. But it's known to host many dwarf galaxies. So here's an image. The Andromeda Galaxy is in the center, a very defined spiral there in the center, kind of almost edge on. But then all these little circles, these are all the satellite galaxies that are in orbit around Andromeda that it will consume over time. So the
Jackie! Sorry.
Are you okay, baby? You gotta be careful.
We got a
He's
Jackie for
got-
the people in the podcast listening.
He's got he's very sensitive.
Good old
Very
man.
sensitive boy. Right there he is. Leia came over because Jackie
General
made a
Leia?
squeal. Let me go to this camera. Oh, he hates it so much right now. He hates it, but he's so damn cute. Okay, so the lead author of this study is Alex Murrow from the Department of Physics at Durham University. And they used ESA's Gaia mission, which have a wealth of accurate proper motion measurements for more than 1 billion stars across the Milky Way galaxy.
And for more on the Gaia mission, check out our shot on Gaia.
Check it out. And so basically, astronomers can look at this data and they can go back in time to basically recover the orbits of the satellite galaxies to see like where they were and where they're going, kind of a situation. And all of this data together can gain insights into how satellite galaxies are shaped by the physical processes as they orbit their large host galaxies. So they wanted to understand how galaxies are quenched.
Super
How
soakers.
galaxies are what?
Quenched. Now, I did not realize until I saw this word appear more than once that quenched is an astronomical term. It's an actual science term. Quenched.
Really?
I was like Gatorade. It's quenched. It's like okay, thirst quenchers kind of a thing. But no.
You're not thirsty anymore.
Quenching refers to the shutting down of star formation within a galaxy.
Wedging.
It's
I had no idea.
I had
did
never heard
not
that.
know that.
I am adding that to my useless facts.
Yes.
And
Isn't
people
that
will be
great?
hearing about this next next week.
Isn't that great?
Or the week after that.
So basically, if you hear like that a galaxy has been quenched, it's that it doesn't have any more.
It's done.
Galaxy formation.
It can't do any star formation anymore.
Wow.
And so
That's actually
Okay.
that's like truly epic.
So the big galaxy
So the
has
big
quenched
galaxy-
its thirst of
yeah,
gas
because
on that.
it's slurping up all that gas, and so it's quenching that galaxy of gas, so it can't do any more star formation.
Its thirst is quenched.
Yes,
I guess
Huh.
It's
that
been
makes
quenched.
sense, but
it's the ultimate Gatorade.
it's the ultimate game.
I wanted to throw a Gatorade joke in there, so that was my lame
Well, you
attempt right
did.
there. It wasn't
You
great, but
ended up
whatever.
doing
It's
it.
what I came up with anyway. So the present predictions for proper motions, infall times, and times of the first paracentric passage. Paracentric means the closest that the galaxy gets to Andromeda, basically, that the
Okay.
satellite gets to Andromeda. For 39 of Andromeda's satellite galaxies, they presented these predictions for 39 of them, and they found that only the most massive satellites of Andromeda can maintain star formation for more than 3 billion years after they've reached the closest approach to Andromeda. Smaller satellite galaxies, however, get quenched. And some of them
Are
some
they
of
like
them-
in the splash zone?
Yeah, exactly. So some of them actually get quenched before they even get to pericenter. That even before they get even close close to Andromeda, they're quenched. Andromeda's just like that fucking powerful.
Wow.
Yes, Brandon.
Thank you. Is paracentric specific to Andromeda, or is that just a generic term to?
Generic term.
Okay, just checking.
I think it's
Yeah, I
like
was just-
perihelion.
So
Yeah,
I think
okay.
paracentric is for the galaxies.
And I think after the sun, they were like, all right, we're not going to do this
Yeah,
anymore.
yeah. So some of them are quenched by reionization, where the gas is heated up by UV radiation, and so the gas gets superheated enough that it's able to escape from the galaxy.
Mm-hmm.
And most very early on are quenched by what the researchers call pre-processing. Not as fun as quench. They should have came up with something like.
This sounds like such like we're in a factory.
It's like baloney.
All right.
We got a
Pre-processing
before the
baloney.
quench stage.
Yes. I need that.
So satellite galaxy. So this basically, the pre-processing is when a satellite galaxy has spent time near a different host galaxy with a lower mass than Andromeda, and this pre-processing can heat the gas enough to remove it, leading to quenching before it even gets to Andromeda. So
It's pre-quenching.
according to the lead, pre-quenching, yes. According to Alex Merrow, again, lead author of the study, the properties of M31 satellites reflect the fact that environmental effects, ram pressure, tidal stripping, or the cessation of gas accretion are reliable quenchers of low-mass satellite galaxy in the universe. That's what the conclusion of the study is.
Reliable quenchers of low-mass satellite galaxies. God, this is a
I
neat
think
show.
they just wanted to use words. They just did this stuff.
What is this,
They could use,
Hamlet?
like,
Words,
some
words,
They
words.
wanted to bring quench into the awareness of.
Stop
the
trying to make
popular-
And
quench
they've
happen.
done it, and we
You can't make
we,
quench happen. Quenches.
We have
Quench
helped
Shakespeare
them.
does.
and Mean Girls in the same sentence.
We have helped them, and if they get a Nobel Prize, we should get credit.
Okay,
I agree.
Yeah.
We contributed.
Because
We
Um,
brought
as
quench.
as we
we
will
put
find
quench.
as we will find out in the Hangover book Einstein's Shadow, who gets credit in Nobel Prizes is actually big amongst discovery conferences.
It is. That's true. That's true. All right, Jack's leaving. He's got a Friendsgiving, but goodbye and enjoy. Cheese fondue, Taiwanese hot pot. Oh my gosh! Happy Thanksgiving, Jack. I hope
Hot
you
pot.
have a great.
yeah, happy
Have a
Thanksgiving.
great
Yeah.
one. Yeah. And meanwhile, since that was the last article for High in the Sky for December 2025, where I think we got quenched
Quench in science.
on our science. Our science has been quenched. Thanks for joining us, everyone. There's lots of stuff to see in the night sky, so of course go outside, check it out, see what's up there. Of course, if you're
Watch
in
the
northern...
entrails of 3200 Phaeton.
Yes, the Geminids. So check those out. Of course, if you're wondering what happens after the episode, if you hear us mentioning something like, "Oh, we'll talk about that in the Hangover," well, we have
That's
the
a chance.
Hangover of this episode, where we will not only talk random things that I don't even remember what we were going to talk about or what came up in the main show already, but we will be doing our book club episode on this
Finally.
Hangover
Sure,
for
yeah.
Einstein's Shadow. We'll be discussing that book, so you can, if you aren't with us live, you can check that out the following Saturday from the release of this episode. But
There's a lot of math
anyway,
in there.
Yeah. Anyway,
Following.
thanks for joining
Anyways,
us.
yeah.
Follow
See
us
us
on
in
all the
2
things,
weeks.
and yes, we will be back in.
oh, like and subscribe.
Oh, yeah,
Oh,
like
whatever
and
it is.
subscribe.
Yeah.
Like and subscribe.
Those things. Whatever. Like
We're
and
so-
subscribe.
We're just so bad at socials. Anyway, bye
Sorry.
everybody. Have
Cheers.
a good.
Bye.
In
Hope
2
you had a
weeks.
good Thanksgiving. If you're with us now live, stick around. We'll be right back with the Hangover and Book Club.
Bow, 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 bow.
Bow. Hangover time. Bow, 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 pew, pew, pew. Bow,
We did it.
bow,
We
bow.
made it.
We made it. We made it. We're feeling good. I'm glad I ate a sandwich earlier. I'm gonna say that.
We could really use some Korean corn dogs though.
Oh my
Well, some
good
of us can
Oh,
get them.
God.
the cheese pool on those things are unreal.
Some
I
of
didn't know
us,
there were Korean hot
some of
dogs.
us can get
Like,
Korean corn dogs,
Why is Asian
and
food the
then
best?
others are
yeah,
just
like
now letting us know about it
so
in the
so so
chat.
in this country, when we go to a truck stop in the middle of major cities, like 2 hours into the road trip, like you're expecting an outhouse and maybe a vending machine, right?
Yeah,
Like that's
yeah,
what you expect.
yeah.
But in South Korea, it's a magical land because you go into this truck stop, but it's a small mini mall. It's like a small city with like, I kid you not, dozens of shops and stalls and food trucks and food stalls and things like that. And there's just a variety of anything you could want. I got some fantastic chopsticks from a food truck out there. But the food is there's a small food mall, right? And
Mm-hmm.
you would typically order it, and sometimes like a robot delivers it to you, for example. Um, these corn dogs, though, are unreal. I cannot describe to you how great, how the texture these corn dogs have, the crispness to them, the sauces, again, the cheese. My God,
Mm-hmm.
it's incredible.
So
Mm-hmm.
basically, South Korea took an American thing and just
And
absolutely
made it
improved it.
better. They perfected the
Ugh,
corn dog, which I didn't know you could do.
I know. I
Oh,
mean,
I want a corn dog now. I'll even
well,
take an American corn dog.
well, we're having either chicken or a pumpkin bisque.
Cool.
Oh, that sounds delightful. Y'all have nothing to complain about.
Wait a minute, what kind of bisque?
Pumpkin,
Pumpkin.
because it's Thanksgiving time.
Oh, not a brisk. Got
No,
it. That's better.
bisque. It's like a soup. It's a soup.
I know.
I'm explaining to Mike that it's a soup with cheesy bread,
There's the cheese. All right.
crouton type, cheesy crouton bread. I don't know.
And there's
Cool. All
Thanksgiving
right.
this week, so
Yeah, we're
there's
gonna
no
get.
need to dive in.
No one's losing weight this week. Is what's gonna happen.
All right, Brandon.
We're like a supermassive black hole at this
We,
point.
yeah.
What were we
All right.
supposed to talk about last
Speaking
week?
speaking of super massive black holes, welcome to the second uh bi-ish month-roll. I don't know what the word for that is. Book club. Yay!
Yay!
So hopefully you have already picked up this wonderful book, read it, dissected it, split it up into segments with notes, things to talk about, and various highlights. But it is Einstein's Shadow by Seth Fletcher.
Which I didn't realize until I read like the end, like his end annotation, that the author basically was hanging out with these dudes, absorbing like pretty much
Oh,
his whole
He
process.
told
How-
that in the
Yeah,
he said that in the book.
Oh,
The main
But-
thing.
I guess I
where
didn't realize
where he's
that,
given
or I
like
missed
all
that.
this unprecedented access.
oh, I
yeah,
guess I
but
didn't
but
realize
like
that.
so many of these books, there's always like a journalist embedded in with this group discovering new things. One of my favorites is Soul of a New Machine, talking about one of the first processors out there, and this journalist, you know, um, writing down every single step, every single small decision that ended up impacting the end result, and that's exactly what happens here. So yes, it is about the team, the Event Horizons Telescope. It was a global consortium of scientists, of astronomers, of sites that created a telescope the size of the Earth to go image for the first time the supermassive black hole Sagittarius A star in the center of our galaxy. So yes,
Oh,
there's
not just
lots.
that one.
Oh no, there's others as
Yeah.
well. At least one other.
M87.
And because you
M87.
basically needed a telescope the size of the Earth
Oh yeah.
with to be able to measure the certain like wavelength and radio to be able to
Mhm.
see the shadow of a black hole.
So,
because we
yeah,
couldn't do
so-
it otherwise.
I'm positive that Mike will talk about that in depth as to why that aperture size is needed. But one of my favorite things about this book isn't necessarily about the science, the process of it, explaining, the hairiness of black holes, the singularities, the quantum of it. But what I appreciate of this book, it's talking about the personalities that impact the science, the bureaucracy that impacts the end result. Like
And
we want to
that's
say
what I
science,
enjoyed.
yeah. We want to say the science is straightforward. Like, okay, go look at the thing. Here's what you need. Here's the process to do it. Here's what you need to improve. Go do it. But that's not at all how it works. It's here's what you need to do. Okay, but here are the different tentacles you could follow to get to that process, and
Mm-hmm.
that path is influenced by personalities, by people, by budgets, by windfalls. It's just fascinating,
Yeah, it
to
was
me at
really
least.
it was really interesting because I never really thought of that side of science, and everything
Hmm.
like that. When I remember when the black hole image came out, and it was like, ooh, wow, and big unveiling, and it was all this stuff. But then I didn't know that underneath all of that was
Oh
basically
yeah.
not just years of the technology development for it, but it was just like the years of negotiating for funding and for, the use of the various telescopes to be on
Right.
board to
Hmm.
participate in this. And then it's not just like, yeah, maybe it was like a couple people or one guy and then a couple people that kind of like started it, and then all these other people glomming on to the project that they ended up needing,
Yeah.
or became gatekeepers to the project. And it was just
Right.
like
So
crazy
so
Yeah,
how much
let
but
let
humanity was
yeah.
and human
So
but
bullshit was
let's
behind
let's
it.
talk about a why the mission was important. Uh, and to get into that, talking about these small decisions, I'll read one quick paragraph, and this kind of funnels into the small decisions that were made, the small personalities, and the small weird things that all
they're
had
not
to
small
align.
personalities.
No,
It's
no, no. Personality's not small. I apologize about
yeah,
that. Personalities are very big.
yeah.
But some of the decisions that those big personalities make are kind of small decisions that impact the whole thing. So, for
Right.
example, um, in this Event Horizons telescope, and really quick, we should explain as well what we mean by different sites around the world to make this aperture. So I know this will make Mike happy. So, Mike, do you want to explain why we need multiple sites around the world to make a telescope the size of the Earth?
Well,
Basically, the bigger the better.
it's called interferometry.
There you go. The bigger the better. Um, However, though, you need to. Um, so, the bigger the telescope, obviously, the better, because it brings in more light. You
Hmm.
get more data. However, radio telescopes are a little bit differently. They operate a little bit differently. But what's really cool though is you can have one telescope, say in say Arizona,
Hmm.
which the the Event Horizon Telescope now actually has in Arizona. You can have one in
Is it not
Chile.
there?
You can have one
Hawaii.
Hawaii. You can have one. All these sites all around the world, and even though the individual telescopes are small,
Hmm.
when you add them all together, they end up being the size of the Earth
Together
because
we are mighty.
together we are mighty because of this thing that Liz said, which is interferometry, where you can take the light that one telescope gets,
Hmm.
add it to the light that another telescope gets. There's some complicated math that happens, but
Hmm.
you can combine them
And
together.
sinking,
Hmm.
And what?
sinking,
Yeah.
Lots of syncing. Got to
lots
make
of
sure it's the
sinking.
exact same time.
And you basically end up with a telescope the size of the Earth, even though your individual telescopes are nowhere near that
Yeah.
size.
Yeah.
And you're able to see, like I said, the bigger the better, because the bigger means that you can see finer
You
detail.
can the bigger you can see smaller.
The bigger you can see
Yeah.
smaller. That's a great
Yeah.
way of saying it.
So so with that in mind, with all these different sites around the world syncing up, you need a way to sync them up to make sure they are in time. That's where things like atomic clocks
Mm-hmm.
come into play, for example. And so these atomic clocks, in a lot of cases, had to be shipped around the world to get to these sites to make sure these telescopes are in sync with each other and can, be sure they're seeing the same thing at the exact same time. So with that, I'm going to read a quick paragraph from this book to kind of show how these small decisions could have impacted giving Sagittarius a picture in the first place. Um, and so in this case, an atomic clock was shipped down to Mexico, and this was going to one of the highest observatories in the world. And this, once it was shipped down, it only had like 72 hours, I think, to be set up before it had to be shipped back to its original place to be reset up again. So like they were under the clock here to get this in. So with that, I should also say the individual Chet Dolman, who's basically lead scientist, the lead project manager of the Event Horizon Telescope. He's a main character in this book, and so that's kind of the perspective we're seeing here. Shep was sitting shotgun in a Chevy Suburban belonging to the Mexican government. Eric, the air ride truck, led the convoy, and his fear of potholes, botches, governed the place. On his iPhone, Shep called Jonathan Leon Tavares, a local astronomer who is riding in another truck, and asked him to gently nudge Eric into driving faster. Quote, so we have to get up to the top of the mountain tonight, Shep said. I'm a little worried that if we go too slowly, we'll be going up the mountain in dark. We're behind you, and we have the hazards on. Muchas gracias. So Shep hung up the phone and said, okay, we're going to speed up to 70 kilometers an hour. And then slowly the caravan reached its new velocity, and the ride was eventually smooth. This is beautiful, Shep said. So had they kept the original velocity, what it was, 40 kilometers an hour, they would not have reached some of the time, and they would have sent the atomic clock back, would have set the whole project back, which may have lost the site, lost funding. So these small things, speed up to 70 kilometers an hour, could potentially
Which is
save
drive
the entire
faster.
program.
In American, it's just like 45, 50 miles an hour.
Yeah.
Originally,
They should
it
have
was
had me
30.
driving.
They went
But
from
again,
30 to
They
you
50.
have
me
this
driving,
incredibly
no
delicate
problem.
machine behind you, so you don't
Yeah.
want to hit those botches, those potholes, and accidentally break something. And in fact, once they get up there, they have to wear oxygen mask and work like 20 hours a day to set this thing up to make sure it gets done. So it's just these small things.
Yeah. Yeah, that's one thing that I was like, it was crazy how much, first of all, they're traveling
Oh yeah.
all over the world and they have just these specific time deadlines that they have to get things done by, especially if they're going to Antarctica, where there's one part where they were setting stuff up in Antarctica and they had to do it in a certain time or whatever, because then it was like there was going to be no flights in or out once it gets to the like winter season or whatever. So they had, and then there was one part where it was like something that somebody had like, it was like their design on something, or they had fixed something, and then it was like, okay, leave it here and hope it works, or do something, or you ship it back, have the person work on it or fix whatever or do whatever needs to be done, and then it gets shipped back when it's ready. And so it was like these decisions of like, okay, what do we need to do, what can we do, what do we sacrifices do we make or not make in order to, you know, stay on track, stay on time, you know. Do we push things and then delay an observation run, or
Yeah, which you don't want to do.
No, because if you delay an observation run, that may be okay with 3 sites, but 6 sites, for example, may say, "Oh, we've already dedicated time for this other group to come in, so you're out of luck for the next 6 weeks."
Right.
So that's more money, and you have to go out,
There's
to get
funding
more funds back
issues.
in.
And that's one of the things, though, is when you're thinking about, so it's one thing when you have, say, a James Webb, right? It's a single telescope, and astronomers book time on that telescope for their various research that they need to do. But the thing with the Event Horizon Telescope is because it's not a single telescope, it's a collection of telescopes around the world. These telescopes are not just used for this one thing. They're used by astronomers all over the world for these various research projects.
Yeah, and even to that point as well, they mentioned this in the book. They wanted to get the Atacama Desert's large millimeter array telescope on board. But in order to do so, Shep Dolman and the whole Event Horizon Telescope team actually had to say, well, if another team has a better proposal, that then they have to give up their time to this new team. And Shep's team is the one that's actually proposing this in the first place. So the fact that they can go to another telescope saying, hey, we have these other 12 sites around the world ready to go look at the Event Horizon Telescope. Are you on board? And they're the best telescope in the world, so they have to be on board, basically. And then they say, sure, we're on board, only if another team applies and beats you, you have to agree to it. That's why, like, no longer is it like a Galileo or a Herschel looking up at the sky with their one telescope making these discoveries. You have to have these teams and bureaucracies in place at this point.
Right, and that brings up like one of the takeaways that I had with the book was how competitive, how the personal angle with this is like, you know, the competitiveness for one thing, but also how if we're working on a project, we see, and this is true for everybody, is, you know, basically these astronomers end up being people, you know. They have definite emotions and things that drive them and stuff like that, But like if we're working on a project, we tend to think of our project as the most important thing that there is. And somebody else coming in with a more important project, and to be honest, that's like a very subjective thing. Like if you're wanting to use the Atacama, for example, there was a specific example in the book. I can't remember what it was, but like if you wanted to use the Atacama, but the guy that runs that observatory has a friend who also has a project. They might think that one is more important, and
Yeah.
so yeah.
Yeah, so there is a process to get to the Atacama telescope. That you have to make a proposal, it goes through a committee. But there's also I forget exactly what it's called. Let's call it the chairman's resolve. That's not what it's called. But the chairman's resolve. The guy in charge can say, "Yeah, I have some personal time. Come on and use it." So you can bypass the whole bureaucracy, which is something Shep was trying to do, but couldn't quite get into good graces because he couldn't get his other site on board either, unless Atacama would agree to it. So there was this whole back and forth.
And let's not forget that, let's not forget because, we read it, but
Never forget.
I mean, he has a very strong personality,
Yeah.
and that can rub other people the wrong way.
Yeah.
If I'm doing something and somebody comes in really hot, I will then really and truly I'll start to drag my feet.
But at the same time, can the soft personality get, a dozen scientific institutes on the same page for the exact same time and get $20 million to do it?
No, you do need that strong personality, but it can
walk the line.
You have to be able to walk the line, and it could rub some people the wrong way, and that could affect you actually getting into that observatory.
What was also interesting, what I kind of was like, you kind of feel a little bit because it's like kind of like for Shep and his team, it's like it's their project. They're the originators of this whole concept of this Earth-sized telescope to observe, to see the shadow of a black hole, but the fear was that another team would be able to use the technology they're developing and get the time before them, make the discovery first, and then that team gets the Nobel Prize when they have spent years
that's the whole
bringing this together.
Yeah, and even more into that, there was another team. I can't remember the team name off the top of my head, but they kind of suggested something vaguely similar, but it was clear they were not going to get the funding. But then they had this consortium of the Event Horizon Telescope to come on in, and this team merged with Shep's team. And then there's a big fear for 2 years of, are they going to get credit, even though they didn't do the legwork to actually see this black hole?
Yeah. That was a big kind of thing, was who's going to get the Nobel Prize if this succeeds?
Which you love the idea that people say, oh, we don't care. We just want science for science sake, doesn't know the truth. And for some people, that's true. However, if you do get that Nobel Prize, then you have that scientific weight. You get more funding for future projects as well and go discover other things. It's difficult.
The Nobel Prize for right now is immortality. And we remember the Nobel Prize laureates before we remember the
small people.
I was also on this particular study because in the end, if you get the Nobel Prize for whatever, you only get it for 3 people. That is it.
Yeah.
And per year.
Yeah.
And it's going to be kind of a one and done. It's not like they're going to give you a second Nobel Prize for another 3
Nobody
people.
gets an honorary
and it's
Oscar.
way more than 3 people. At this point, there were hundreds of people. And as an example, there was a grad student, Katie Bowman was her name. She created a data set called CHIRP, which was continuous high-resolution image reconstruction using something called patch priors. For more of that, read the book. But basically, CHIRP, it would use tiny pieces of existing images, and it would be able to construct, okay, this is the time of day, this is the conditions the telescope was used in, this is what it was looking at, and it could use other telescopes' data using that same patch method and figure out where the alignment was actually at. So you could compare all these different telescopes' data around and figure out the exact second it was being used in. So a grad student was able to use that helped contribute to the Event Horizon Telescope as well. She didn't get credit in the Nobel Prize, but it goes to show all these hundreds of people that work into the effort contribute to it.
But if it's who I think it is, they got credit in the announcement. They actually played a really important role in the announcement. In the press conference, I think she played, like, she was given, she's not getting Nobel Prize, but she was given a lot of prime time.
It's like getting a good shout out of all hands, right, guys?
Yeah, but she got to do the prime time announcement and talking about how they did things. And there's no Nobel Prize for that, but it's going to be good for future jobs. And
one of the things that I was kind of like struck with is, okay, so we have these physicists, astrophysicists, and whatever, and they're like thinking about black holes and all this, but then at the same time, they're also able or have somehow at some point learned how to then MacGyver these telescopes with engineering to make it so that they can install an atomic clock and all these other things that make the telescope do what it needs to do to get the result that they want to get. And I'm just like, what are they learning in school to be able to know all these other engineering things and whatever in addition
it's MacGyvering 901.
The physics behind everything? Like, how do they know how to manipulate the telescope? And then also, it's just like there was just so much more that everybody seemed to know that was not related to the physics of a black hole and the accretion disk and all this kind of stuff that they were aiming for to learn about.
I love a theorist. I feel like a theorist sees the universe in a way that other people don't. And they're able to come up with a more fundamental understanding of the universe. However, in experimentalist in physics or somebody who does observations in astronomy, they have to not only understand the physics of something, like in this particular case, what would happen if you try to take a picture of basically an accretion disk of a black hole, that type of thing, but you also have to understand the engineering. You're basically an engineer and a physicist, which really and truly at the end of the day trumps a theorist. But they
Well, you have to have the theorist.
You do have to have the theorist because
someone's got to think about the problems. The other people have to solve the problems.
In this particular case, you do have to rely on Einstein. You are attached to the general theory of relativity. The general theory of relativity makes a prediction, and that is actually what you're taking a picture of. You're either going to prove Einstein, or you're going to not prove it, or you are going to get a Nobel Prize for proving him wrong.
And that's not going to happen.
But at this point, it's been proved right.
Every single time. So punchline is that Einstein's going to be proved right in this particular case. But, you have to not only understand the physics that gets you the image that you expect, to where you can say, yeah, Einstein was proven right again, or, hey, damn, Einstein was proven wrong. Hook me up, Sweden. I want that Nobel. But also it's like, hey, I took a picture of a black hole. Sweden, hook me up. I want that Nobel Prize. But you also have to be able to understand how you can put in an atomic clock to this, how you can connect these multiple radio and infrared telescopes, radio telescopes in this case, and also process the data. These are
terabytes, petabytes.
It's not like they're getting pictures back. The pictures are created from the data that they get. But the data has to be processed, like a huge amount of data has to be processed, and then eventually it's turned into an image.
It's similar. It's similar to when. Sorry, it's similar to when we had the first spacecraft land on Mars, and we did get color imagery back. We got ones and zeros and X, Y, Z's, and so people went in and colored it, basically, literally with colored pencil in the case of Mars.
Yeah.
So it's similar.
Yeah, and the book talks about how, like, they're transporting hard drives and shipping hard drives from
Physical
one site to another site. Well, and the other site is it's in, is it Harvard? I can't remember. It's in New England, and so they are shipping these hard drives so they can analyze the hard drives. They're shipping atomic clocks. Wasn't there one that went to Russia, or there was one that went somewhere? And I don't. That's great. All right, so we're gonna have a cat that's just gonna jump into the scene here pretty soon. But anyway,
Indiana Jones cat.
I know.
Oh no! Don't.
I know that, like, for some that there isn't.
No.
Like with this book, you don't have the action that you're expecting. We're so used to, like, an action movie. There's so much action, like motorcycles going through Rome, being chased by the cops and shit like that. But exactly. But there was a lot of, like, action in this book that was. I just wasn't expecting it in a lot of ways.
To make a very quick tangent, one of my favorite Twitter accounts back in the day was something called Observatory Cats, and it followed the cats around Arecibo, and it was delightful. It reminded me of when we about to have a cat in this episode. So anyway, R.I.P. Arecibo.
Observatory cats.
Rest in peace, Arecibo.
Right. Oh no. Okay. Anyway, now, of course, the goal wasn't just, I mean, the goal was, like, to take a picture of the black hole, right? Or the shadow of the black hole. But it wasn't just to take a picture.
The goal was to take a picture of what Einstein predicted, which happened to be the shadow.
And it's really to understand how the physics around a black hole works and how the accretion disk, works. And that is the goal, and not to just get, like, a cool fucking picture and a never before seen picture or anything, which is a bonus. But there was science behind it.
All the really cool shit that, like, science puts out, it's like, that was not the goal. The pictures that, like, James Webb, that shows the general public. The pretty picture
is not the goal.
It's a pretty picture. The pretty picture is not the goal.
But it's a bonus.
The science behind the picture is the goal.
Yes, but then there's a point as well. Like, I don't think it was Juno. I don't remember what it was, but there was a spacecraft sent out to a planet, and they said, no cameras. We don't need it. We just want the science. But the fact that the public gets the pictures and the public ends up funding the science, that needs to be done.
That's the public engagement.
I'm not saying that it doesn't need to be done.
No, you have to have the pictures.
You have to have the picture.
Pixar didn't happen.
I only brought that up because I did highlight, one of my highlights was that, a quote from the book from page 62, but that simulating...
On a Kindle.
On the Kindle, yes. My Kindle. Simulating black hole accretion is like modeling the weather in hell. And I just thought that was fun.
Yeah, I mean, it's chaotic.
Oh, no, 62 in the book as well. First sentence of the second paragraph. There it is.
And I was like,
Yeah, I mean, it's... I feel like I should have brought my Kindle now, but I was like, I'm just gonna wing it.
And also, I had this. So I did a few highlights as I was going, and then I kind of forgot about highlighting stuff. But that there was a fact I didn't realize, and this I guess helped to prove continental drift. Was that there was there's just the part that I don't know what the originator was, but the time delay between the telescopes changed over time. They knew it. They were observing a quasar. They knew it wasn't because the quasar was moving. It was because the telescopes were moving, which meant that the continents were moving. So they have to account for continental drift.
For more on that, check out the shot episode, Black Holes and Continental Drift.
Black Holes and Continental Drift. Shoot it down your gullet. Through your eyes and your ears.
That's where I got the idea from. those many months ago was that exact
Was
paragraph.
that right
Yeah,
there?
but
Yeah.
none of this happens in a vacuum, right?
Unless it's
Well,
space.
unless it's in space. Damn it,
Oh.
Liz.
All right, but is there really a vacuum in space?
Is there? Well, there could be.
No,
Have you seen
no.
Spaceballs?
Every
Damn.
square meter has particles, has light passing through it.
What?
Every cubic centimeter has particles passing through it.
There's a lot of empty space, though.
There's a lot of empty space.
One of the things that gave me a chuckle was early on in the book was basically talking about like just how much our brains process now, and that the fastest things our brains ever had to process during those formative millennia on the savannah was a sprinting cheetah.
That's fast.
Like
real
that
fast.
was the fastest thing.
That's at least 71 miles per hour on the land.
71, and that was 60.
I thought it was 62.
Cheetahs, I may have been 67.
Okay,
But-
between
Between 60 and
60 and 71.
But
So that was
cheetahs are my favorite non-dog animal, so I feel it's at least
Aw.
67.
Cheetahs are cute.
All right, let's just say 71. There's got to have been a cheetah that went 71.
Yeah, so
There's
before
gotta
it was
be,
like
yeah.
the speed of a
The
cheetah
Usain Bolt of cheetahs.
was the fastest thing that we had to understand, and now we're thinking of model. We gotta basically model the weather of hell.
And all right, but to be fair to our brains,
hell.
there isn't like much difference between now and having to figure out the speed of a cheetah. But
They didn't have math.
Oh,
no,
as far as the brains
but
go, the
it
structure of the
is-
brains,
Right.
yes.
Yeah, there's not a lot between us and the
But
guys
now we
that
have
had to figure out.
bureaucracy.
Right. But you know what is amazing though is that how well our brain does physics without doing the math. Like if you're driving in a car,
Some people's brains.
no,
I was like,
no. In all
"Hmm."
seriousness, if you're driving a car,
Mhm.
you're able to mentally do the physics to apply
the
your
brake.
brake to stop
Yeah.
before you hit the car in front of you.
I mean, there was a world in
Generally.
which, there was a world in which people thought 35 miles an hour was too fast for human brains to comprehend, specifically women's brains. But in general, it was something human brain could not comprehend going that fast.
Right.
And here we are now. We have F1 people. We got space shuttle pilot commanders going 6,000 miles an hour,
Yeah, and
18,000 miles an
able
hour.
to process that. Our brains
Even
are amazing.
women's brains.
Even women's brains. That needs to be on the mug.
No. The women's
I
brains.
put the
No. Where Brandon and I can do 6,000, you can probably do 3 if you're lucky on a good day.
I
But
mean,
how
in my
many
brain, I
Skittles is that?
Can't do
How
a
many
lot
what?
of math.
How many Skittles per hour is that?
Oh shit! Yeah, that's a good one.
I'm
So,
looking at my
yeah,
highlights.
yeah. Okay. Oh, yeah, Liz, talk about some of your highlights.
Well, one of my highlights, I thought it was a good visual of the resolving power of the Event Horizon.
Oh, talk about the moon,
telescope.
yes.
Was that it would be able to, if it worked, which we know it does, it would be able to resolve a donut on the moon.
A donut on the
Or
moon.
if you want the shadow of a black hole at the center of our Milky Way, which was
Yeah,
the
but
goal,
you know what I
you could
want?
find a donut on the moon.
I want a donut and a Korean corn
Hot
dog.
Corn dog.
Yeah. And
but also
the
a
be- the be-
picture of the Event Horizon.
But the best thing about the Korean hot dog on the moon is that to eat it, you'd have to rehydrate it. And when you rehydrate it, you
You get
rehydrate the
tardigrades?
tardigrades. Yes. And you get
Check
to
out
eat the
our latest
tardigrades.
episode
God,
on tardigrades.
There are so many levels to that just one little bit.
Just a mouthful of science right there.
And then my last highlight was from just the annotations or whatever, and just this quote of it says, it's talking about the active when a black hole is feeding. So a black hole feeding, it's releasing a lot of energy. Actually, it's not coming out back out of the black hole, but as matter infalls, some of that gets ejected through its jets of the black hole. And so this quote says, in the active stages, the black holes fire jets of matter and energy across the universe, landscaping the cosmos like great rivers, cleave
beautiful.
continents, and build deltas.
And what's great about, heaving that contents into the universe is that if you are a galaxy 500 million light years away, 3 billion light years away, you can look back and still see the remnants of Sagittarius A star as well. You can still see the impacts the Milky Way has on the cosmos in general.
Which
So yes,
it just goes to show like it's all related,
It's
everything
wait.
has an effect.
It's all relative.
It's all relative.
Different, different.
Hey, shh.
No, this is two different things. Related and relative, two different things. All right.
Not in this case of this sentence.
And that's one of my favorite kind of concepts of the universe. I say concepts. I mean, I guess it's a fact because it is a thing that is happening. Is that the universe is basically recycling itself? Because you have all this stuff coming together. Stars are formed. Some of those stars, they explode. Some just kind of puff out their gases, but that material goes out and it has different elements, and that material interacts with other material and comes together, and you have new planets, new stars, new planets, new whatever that is forming all throughout the universe from stuff that came before it in different locations, all coming together. And so it's constantly just recycling itself over just a very long period of time.
Are you saying, Liz, that this is cosmic cannibalism?
And regurgitation.
Cosmic regurgitation.
Is the universe bulimic then? The universe is bulimic. It has binges and then it has...
That's fair. All right. I was to get to the cosmic cannibalism.
Because I love,
right,
I love a galactic cannibalism. I'll take cosmic cannibalism.
Yeah.
So to come back
black
to
holes
the
would be the
book as well.
cannibalizers of the cosmos, though. You get too close, that black hole's gonna eat your ass.
There are millions and millions of black holes zipping around the galaxy.
Okay, you have to explain this context.
Nothing there to wipe them up.
You have to explain this.
Just Google
Symphony of Science.
Symphony of Science, black holes.
Black holes. There's a whole suite of them as well, but black hole specifically is probably the best one. Okay, so there is another book. We're not doing this for the book club because it's very big, but Mike would enjoy it. It's called Green Earth by Kim Stanley Robinson. It's part of its trilogy called The Science in the Capital, and it really dives into one person trying to lead a bureaucracy of science to discover new things. It's wonderful.
All right, Green Earth?
Green Earth. You remember that for obvious reasons.
Okay, yeah.
Mm-hmm.
Is it
It's
like
sad.
Red Earth, Green Earth, Blue Earth?
Something like that.
Oh, okay. All right.
Something like that, yes.
That was one of those things. That was one of the things in the book where it was like the whole forming, like once the project got to a certain size, they basically were forced to make this bureaucratic
Science by committee.
committee in order to organize everything and also kind of say, okay, who is actually at the top of
because the person at the top isn't necessarily doing the science; they're doing the managing, and the person
or it's the money
or the moneymaker. So in this case,
they get the Nobel.
Yeah, so in this case, Shep, the original scientist who thought about this in the 80s and 90s and 2000s and put everything together, he was risen to project manager, but he didn't necessarily want to be a project manager. He wanted to be the person in the trenches doing the science. But if he was risen to the project manager who had control of the program, because he's not doing the science, is he still getting the credit, even though this was his idea, his baby, and now it's all under him? Right. So that was a big question he had.
That was a thing. You know what? That actually kind of reminded me of my dad. So my dad is a
coming in hot.
Yeah. My dad is a retired firefighter, and he actually did not want to become a chief because he didn't want to be behind a desk. He wanted to be in the trenches. He wanted to still, go out on calls and actually, fight
Save that
fires,
cat.
although a lot of it was like medical stuff and whatever, and, that kind of stuff. But he wanted to be actually involved in doing stuff and in the trenches of it and not behind a desk. So I think my interpretation of it, even though I never had asked or got confirmation, my interpretation is he had got the opportunity to become a chief, but he decided to stay a captain because he still wanted to be on the crew and doing stuff.
It reminds me of American Revolution. George Washington had the potential to do 3-4 plus terms, and he says, "No, I am not a king."
Yes.
And he resigns.
And he
So
resigned.
George Washington and your dad are like the same person.
They
Okay. All right.
Yeah, my sister confirms. He said dad hated the paperwork, loved the action. I don't know if I want to confirm.
No, that's the same thing. Same thing.
Okay.
Same
All right.
person.
All right.
Yeah,
They got the
let's
same
go with
grit.
that.
They got the same grit.
Okay, sure.
All right.
Yes.
One had slaves.
What
Okay.
about teeth?
I don't know if he was offered chief at all. I just know that he didn't want
All
to
right.
become a chief. So anyway.
So let's kind of wrap this up here. Let's get back from George Washington's teeth and slaves and your dad back to Einstein's shadow.
Einstein's shadow.
Yes. So at the end of the day, one of my personal biggest regrets was going to the store and not picking up the front page paper that had the Sagittarius A star on the front page in full color. I don't know why I didn't pick that up.
You and your fucking new. Where were we? Where we saw there were old
I was in
newspapers.
Oklahoma City.
When we were at Doug in the UK, we were at the Birmingham Science Center or think tank Science Center Birmingham, and they have an Apollo exhibit, and they had had newspapers in the glass case, and we both were like, "Oh, Brandon."
So one of my favorite gifts I've ever received from my mom and sister is the newspaper right above the monitor, which is the New York Times Men Walk on Moon. I have a number of other newspapers as well, but that one, beautiful. So yes, I like my newspapers because it's a capture of society in that singular moment.
It's a snapshot.
I'm surprised there was. I mean, I guess I'm not surprised. There are still newspapers. Excuse me.
They still exist, yes.
They still exist.
Which we should buy them and contribute to them because they are a great source of news, which is difficult to get elsewhere, especially local news. And when local public news is being dismantled all over the place, it's important to support them where you can, which is why yesterday somehow I became a member of the ACLU. So, donate where you can.
Somehow.
I was donating to our local Oak Ridge, Oregon newspaper, the Highway 58. Although they turned off donations, so I guess I could still donate, but I did donate to
they're still
our
taking
local
money from me.
So
newspaper.
the way the ACLU got me, which I think like 6 years ago I applied for a job for them, but regardless, I was going to our local farmers market, which is right for ACLU people, and one of them goes, "Hey," I go, "Hi." They go, "How much does a polar bear weigh?"
Oh, that's okay.
2
That's
tons.
the thing.
2 tons? Wait, what do you think, Mike?
No, I'm.
How much is a
1
ton?
ton.
1 ton?
pounds.
Okay.
What?
So
1.25 tons.
1.25 tons. And so what he said to me was enough to break the ice. And I go, "You son of a bitch. You got me.
No.
You got me, you son of a bitch."
Especially, the ice is thin now. Especially.
Yes. All right. Well.
Eric says ACLU co-founded by Shapley.
Wait,
Like
what shape?
astronomer?
The Harlow? We talking the
Harlow
great
Shapley?
debate guy? Eric, talk to me here
There's
about.
There's a delay. They have a delay.
I know there's a
on
delay, and we're going to
I'm gonna
have a
Google
moment
it.
here.
Yeah. All right, Eric. We need for you to like Harlow Shapley.
That's a thing.
Dak Shapley. All right. Well, we gotta look into. Are you looking this up?
God, that didn't give me anything.
All right,
Harlow Shapley.
Mike.
Chase.
Put ACLU Harlow Shapley.
Same guy.
Same guy. Harlow
Same
Shapley.
guy? Wow.
Wow.
Wow. Yeah.
I did not.
This is
know
exciting.
Harlow Shapley with the American Civil Liberties Union
go.
was a blah blah blah. With the son is
Anyway.
he was involved in politics and humanitarian efforts, particularly aiding Jewish scientists fleeing Europe during
Project
World War
Paperclip.
II.
Cool.
Shapley
So part of
had
ACLU.
political
So this is
activities that
going
drew
to
attention
be
from
a
government
future
and
shot episode. So with
Oh
that,
wait, this says he was not a leader or a prominent member of the
No, but
ACLU.
he was just a founder. You don't have to be a
Yeah.
leader.
Oh, okay.
co-found doesn't mean one of the two, it means one of the 16,000.
This
Sure.
said there's no evidence to suggest that he was.
Oh,
I
okay.
trust Eric
Oh,
rather than the
Leia.
internet.
Oh, you
Leia.
see.
Oh no. Oh god. Oh
Okay,
no.
so with that, yes, the camera's
All right.
up there. So with that, let's kind of bring things to an end here.
Okay.
So Einstein's shadow to me was great, not because it explained the science.
There's the guilty face.
Oh, puppy
All
dog.
right, let's focus.
So I love when journalists, biographers, for those of you in the podcast, the camera's going left and right everywhere, so I'm taking a moment
This
not to
only
throw
goes
up.
on YouTube. The Hangover only goes on YouTube.
So they see all of
Oh,
this.
okay then.
Okay,
So what I love about Einstein's shadow and science journalism in general, is a couple things. Number one, the pure wax, the poetical wax that they can weave of science and far off objects is gorgeous. Like you can't do that in newspapers, you can't do the magazines, but they're not bought. So I just love when they can really go full ham on the beauties of space. That makes me happy. But also putting a human element on these discoveries, not necessarily about the final results, but about the literal blood, sweat, and tears in
All
every
the
sense of
people
the word
involved.
it took to get
Yeah,
there.
So many
that's
The
what I
people,
like.
the decisions, the small, big
That's-
personalities, everything that went in to get this. It's no longer just Galileo looking to the telescope, to a
That-
telescope.
that is
It's
exactly
thousands of
what I
people.
And it's
love.
also
Yeah,
like
what I
a
love.
lot of times it's like decades worth of work.
Right.
Oh yes, decades.
You know, because we know the final story in this.
It worked. They got
It worked. They got the picture.
Mhm.
We were there when the announcement came down. All this kind of stuff, and so we know the final stuff. The human story to this is
Yes.
what I absolutely loved. How did we get there? And yeah,
Where did we come from? Where did we go?
I thought it was a great book. I thought it was a great book.
Good. I know some people consider that potentially dry, but I just love seeing all these Jenga pieces come together, these Tetris pieces come together, and make the image that became the front page of the New York Times.
It was interesting. I did find it very interesting. I mean, I could see how it was dry, and it took me a bit to kind of like get through it. But then as I was reading it though, I was into it and I was like, oh wow, like so many things that I didn't realize were happening, and also my disbelief where in the fact that the ALMA Atacama Large Millimeter Telescope, where Alma was just like, well, I don't know, maybe
Oh my
not,
God.
blah blah blah, and it was
Right.
like, and in my head I'm like, how could you not make this a
Because-
priority? Because this is like groundbreaking shit that they're trying to do.
Because of
like I couldn't
personalities.
understand
Because it's
why this wouldn't take
personalities.
just so much precedence to make this shit happen.
Because it's personalities. It's personality.
Yeah, but still, I'm like, look at with the science, the possibilities
no,
of,
but it's personality.
so I guess it's where my view beforehand would have been like, oh, who would say no to being involved in this?
So many people,
Where I was
yes.
just so
Because
confounded that
because
people
they're
would
people.
say no.
All right.
Mhm.
Let's wrap this up one final time. So, thanks for reading the book. If
Mike
you
just wants
read
to
it,
get the fuck out.
if you haven't read it, please read it. It's a great book. Thoroughly enjoyed it. If you haven't read it, Einstein's Universe by going
Einstein's
up.
Shadow.
Einstein's Shadow by Seth Fletcher. So there you go. So check that out.
And do we have another?
Yes, we do have another
club
book.
on docket?
That
Since I
other
picked the
book on
first
our
book,
docket.
and Brandon picked the second book. What is your book pick?
I'm getting there.
know.
I'm getting
But Mike, what's your book?
because we're closing
What is
this
it?
out. It is called
What's it about?
The
What is it?
Martian by Andy Weir.
Hey.
People wanted some excitement. This is gonna
Jazz
be some
hands. Wait.
excitement.
Oh,
Nope,
Different
different
one.
book.
Different book.
Jazz
different book.
hands are not in this one. But if you do want to read
But sciencing the shit
Andy
out of
Weir
shit
book that
is-
does have jazz hands
And potatoes.
it is
Fist
it
my
is
bum.
Hail Mary. But yes, exactly. But for us, the next one is going to be The Martian by Andy Weir. Do not cheat and watch the movie. You have to read the book.
If you haven't seen the movie, what are you doing?
Well,
Watch the movie.
I mean,
I was so excited in the movie. We got to the point, and I thought we had like 3 hours left, and there was like 10 minutes left. Anyway, we'll talk about that later.
Okay,
so that is going to be our next.
We will
next
do
one.
book club sometime next year.
Next year, but check us out in 2 weeks where we have a topic on something to be determined.
I have an idea.
I have written out a show, but
Oh, we both have ideas.
Okay, so check us out on December 7th, which is a Sunday. Cheers, everybody.
Whatever that Sunday is.
Like and subscribe.
It lives in infamy.
Do to like and subscribe wherever it is. Cheers. It could be anywhere.
But follow us over here on these.
And check us out on Patreon, which
like
we're not
subscribe
on. We're
down
not
below.
We're not on.
We're not on Patreon, but
cheers.
Whatever.
We'll see you in 2 weeks.
All right,
bye.
bye everybody.
Donate things.
Bye. Well, have a great. I hope everybody had a great holiday.
Thanksgiving.
Good. Bye.
Bye.
And